So, man kann mich offensichtlich hören. Guten Morgen allerseits. Ich möchte mich gleich ein bisschen für die Verspätung entschuldigen. Manche wissen, warum, nämlich die, die mit dem Auto gekommen sind und einen Parkplatz gesucht haben. Das ist leider noch viel schlimmer, als wir dachten. Es fehlen zwar immer noch ein paar, aber die, die halbwegs pünktlich sind, wollen wir jetzt auch nicht länger warten lassen. Mein Name ist Andreas Wierse, ich bin hier von der SICOS BW. Wir gehören auch zum Höchstleistungsrechenzentrum in gewisser Weise mit dazu. Und ich darf Sie heute durch den Tag führen und freue mich, dass Sie den Weg tatsächlich gefunden haben. Ich hoffe, ein paar kommen noch. Und ich würde einfach mit Ihnen mal kurz durch die Agenda gehen und da das ein oder andere Organisatorische vielleicht auch noch ansprechen. Also Begrüßung und Programm, das findet jetzt gerade statt. Wir haben dann 2 Industrieblocks, da ist dann eine Pause dazwischen, damit Sie sich erholen können und vor allen Dingen auch ein bisschen austauschen, auch mit den Referenten sprechen. In der Regel ist es so, dass die Referenten, also ich weiß bis jetzt noch von niemandem, der gleich weg muss. Das heißt, alle sind auch noch länger da und stehen für Gespräche zur Verfügung. Wir haben 2 Vorträge in der zweiten Runde, die online stattfinden, weil beide Teilnehmer kommen aus Berlin oder sind aus Berlin. Da war es ein bisschen schwierig mit der Anreise, deswegen haben wir gesagt, die beiden sind online. Wenn da Fragen sind, dann sollten Sie die direkt stellen. Wir haben ja immer 20 Minuten, das ist so angedeutet 15 Minuten Vortrag plus dann 5 Minuten Zeit für Pause. Ich werde versuchen, den Zeitplan auch entsprechend einzuhalten, also auch bitte auch an die Referenten da ein bisschen drauf zu achten. Genau, das ist sozusagen dann der Vormittag bis etwa 12 Uhr. Um 12 Uhr haben wir eine Speed-Dating-Vorstellungsrunde. Ich muss gestehen, ich habe mit dem eigentlichen Speed-Dating noch keine Erfahrung gesammelt, aber so ein Experten-Speed-Dating, das habe ich schon gemacht. Das ist auch der Hintergrund hier. Aber im Gegensatz zu dem, was man normalerweise beim Speed-Dating macht, wo man einfach an den Tisch kommt und einen Partner sieht, haben wir uns gedacht, es ist vielleicht nicht verkehrt, wenn wir Ihnen die Speed-Dating-Partner vorher schon mal vorstellen. Das heißt, ab 12 Uhr haben wir 6 Slots, 10 Minuten, wo jeder der Experten, der später auch zur Verfügung steht für die Gespräche, schon mal so ein bisschen pitcht. Das macht es, glaube ich, ganz einfach. Also es macht es deutlich angenehmer und einfacher. Das hat den Vorteil nämlich, dass Sie, wenn Sie beim Speeddating dabei sein dürfen, dass Sie dann schon ein bisschen was wissen und derjenige gleich sozusagen, Sie können mehr sprechen. Ja, also es geht ja darum, dann Fragen zu stellen und dann muss der Experte nicht mehr erklären, was er alles macht, damit Sie dann überlegen können, welche Fragen Sie stellen, sondern das können Sie alles vorher schon machen. Genau, so, apropos Speeddating, das eigentliche Speeddating ist ja dann nach dem Mittagessen. Um 13 Uhr haben wir 1 Stunde Mittagspause eingeplant, auch da, um sich auch austauschen zu können. Und das Speeddating ist dann ab 14 Uhr, da haben wir 2 Parallelsessions. Das Speeddating selber wiederum hat auch nochmal 2 Runden. Und wir haben jeweils 6 Experten, beziehungsweise wir haben 6 Experten, die müssen zweimal arbeiten, aber in der ersten Runde dürfen die von Ihnen mit den Experten sprechen, die einen blauen Marker auf ihrem Namensschild haben. Und die zweite Runde ist für die, die einen gelben Marker haben. Und das Speeddating findet hier statt. Wir werden schauen, dass wir die Experten ein bisschen so weit auseinandersetzen, dass man sich trotzdem gut unterhalten kann und der Geräuschpegel nicht so groß ist. Das funktioniert erfahrungsgemäß wirklich wunderbar. Die Parallelsession zum Speeddating ist die Rechnerraumführung. Also hier in der nächsten Gebäude steht auch Unter. Und auch dort wird es 2 Runden geben, sodass also auch die Speeddating machen, wer in der ersten Runde ist, kann mit der zweiten Rechnerraumführung gehen und umgekehrt. Die Rechnerraumführungen sind auf 10 Personen begrenzt, aus Sicherheitsgründen. Ich glaube aber, dass das ganz gut funktionieren wird. Aber seien Sie nicht traurig, wenn also wenn Sie der 11. sind, es sei denn, Sie haben dann die zweite Speed-Dating-Runde, dann sollten Sie vielleicht versuchen, mit jemandem zu tauschen, der keine zweite Speed-Dating-Runde hatte, damit Sie auf jeden Fall auch Hunter zu sehen bekommen und was es da sonst noch so gibt. So, und nach dieser ersten Parallel Session, also A und B, gibt es dann nochmal eine zweite, ich sehe gerade, ein Mehrfach-Parallel-Session. Also wir haben uns da schon, also wir fordern Sie so ein bisschen intellektuell auch, damit Sie so nach dem Mittagessen nicht einschlafen. Nein, Da gibt es dann die Möglichkeit, wenn Sie, Speeddating dauert so 3 bis 4 Minuten pro Partner. Ja, das heißt, das ist tatsächlich, ist ja der Sinn der Sache, dass man sich beschnuppert und feststellt, boah, das könnte interessant sein. Wenn Sie feststellen, dass es interessant ist, dann können Sie sich vorne am Counter melden und quasi für die Session C, das Second Date mit Wunschexperte, sich einfach anmelden. Ja, also einfach Bescheid geben. Entschuldigung. Und dann schauen wir, dass wir möglichst Sie auch noch mit dem Wunschexperten zusammenbringen können. Ich hoffe mal, dass das jetzt von der Menge, dass Sie nicht alle dann zu einem und demselben Experten wollen, da wird es ein bisschen schwierig, da müssen wir gucken, was wir machen. Aber ich glaube, so tendenziell sollte sich das halbwegs verteilen. Diese Session, die geht tatsächlich auch bis, also die mit dem Wunschexperten bis 16:45 Uhr. Also da sind dann schon, da kriegen wir schon 5 20-Minuten-Sessions unter. Da bin ich ganz guter Dinge, dass wir das hinbekommen. Um 15 Uhr findet dann hier im Raum, genau, also die Vertiefung, das Second Date, das findet dann individuell statt. Also da werden Sie dem Experten zugeteilt und wenn Sie wollen, können Sie rausgehen, wenn es nicht regnet. Aber der Raum selbst hier ist dann ab 15 Uhr mit einem kleinen, ja, man kann schon sagen, Kurs. Der Dr. Deljegev wird Sie in die Basics der Supercomputernutzung einführen. Und das bedeutet tatsächlich hands-on. Sie sehen, da sind hier, das hier ist ja auch eigentlich ein Schulungsraum, auch ein Trainingscenter. Da sind Laptops und wenn Sie diesen Kurs machen, dann dürfen Sie den tatsächlich aufklappen und dann können Sie hands-on tatsächlich auch, weiß jetzt nicht, ob Sie was rechnen dürfen, aber auf jeden Fall bekommen Sie wirklich live erklärt, wie das Ganze funktioniert. Das ist die erste Session, die geht dann bis 15:45 Uhr und ab dann gibt es einen Visualisierungsworkshop. Das ist hier im Gebäude. Da müssen Sie sich dann sozusagen, wenn Sie hingehen wollen, dann melden Sie sich. Der Herr Wössner, Dr. Wössner von der Visualisierungsabteilung, der kommt und holt Sie dann ab. Das kann ich auch nur empfehlen. Das ist auf der einen Seite sehr spannend zu sehen. Wir haben da eine 3D Virtual Reality Visualisierung, wo man Simulationsergebnisse und auch andere Dinge wirklich räumlich erleben kann. Und ich habe ihn auch gefragt, was er denn dann macht in dem Workshop. Und dann hat er gemeint, no, die Leute sollen halt sagen, was sie wollen. Also der Uwe ist jemand, der macht das nicht, weil er keine Arbeit sich machen will, sondern er ist also in der Lage, auch auf ihre Wünsche einzugehen. Und wenn Sie keine haben, dann werden Sie mit Sicherheit auch was Spannendes sagen. Aber wenn Sie was haben, überlegen Sie sich schon mal, was Sie ihn fragen könnte, was mit Visualisierung Sie besonders interessiert. Es gibt schon einen ganz ordentlichen Fundus an verschiedenen Demo-Datensätzen. Da können Sie dann sicherlich auch was Spannendes mitbekommen. Genau, und um 4:45 würde ich Sie dann nochmal verabschieden hier und einen Ausblick geben. Wir wollen das natürlich, das ist ja schon das zweite Forum, wir werden das sicherlich auch wieder machen und Sie werden auch im Laufe der Zeit feststellen, es gibt ja auch ein paar spannende Sachen, die wir hier sonst machen, die für Sie vielleicht auch interessant sind. Und genau, dann 17 Uhr ist geplantes Ende. Ich gehe mal davon aus, dass wir da pünktlicher sind als jetzt beim Beginn. Wobei, wenn ich mich jetzt kurz fasse, sind wir sogar gleich passend für die Vorträge. Ich habe noch 2 Kleinigkeiten. Zum einen, weiß ich, nicht jeder von Ihnen hat vielleicht schon die Toilette gesehen, aber die Toilette ist sozusagen da hinten. Es gibt 2 Wege dorthin. Sie können entweder hier vorne rum und dann rechts gehen, aber wenn Sie während eines Vortrages das dringende Bedürfnis verspüren, dann gehen Sie am besten hinten raus. Da müssen Sie nicht hier beim Vortragenden vorbei, sondern Sie können sich ganz leise hinten rausschleichen. Bisschen aufpassen, wenn Sie die Tür einfach ins Schloss fallen lassen, dann sind alle wieder wach. Also die vielleicht leise schließen, aber das ist völlig problemlos. Und dann haben wir noch einen kleinen Nachhaltigkeitswunsch. Sie haben die Badges bekommen. Es wäre wirklich sehr gut, wenn Sie die Badges, bevor Sie gehen, einfach wieder vorne am Counter abgeben. Dann können wir die nämlich beim nächsten Mal wiederverwenden. Sie haben gemerkt mit den Magneten und so, also das sind keine Wegwerf-Badges, sondern die werden hier regelmäßig wiederverwendet. Gut, ich gucke mal gerade, gibt es irgendwelche Fragen von Ihnen zum Organisatorischen? Gut, dann kommen wir gleich zu unserem, ich sage jetzt schon ersten Highlight, aber wir haben ja nur Highlights. Aber es freut mich besonders, weil der Erwin Schnell und ich, wir kennen uns, ich weiß nicht, 20 Jahre sind es locker, wenn nicht noch ein paar mehr. Also ein intensiver Strömungssimulant und auch HPC-Nutzer von der Firma AeroFEM in der Schweiz. Bist du heute Morgen aus der Schweiz gekommen? Nee. Nee, okay, gut. Ja, es gibt auch noch einen Wohnsitz hier irgendwo in der Nähe, gell? Genau. Ja, und bei ihm geht es um KMUs in der digitalen Transformation. Der Weg ist das Ziel. Da bin ich mal gespannt. Bitte.
Okay. Vielen Dank, Andreas, für die Einführung und ich werde mich auch beeilen. Wie schon gesagt, mein Name ist Erwin Schnell. Ich bin seit 36 Jahren jetzt mittlerweile im CFD zu Hause. Die letzten 5 Jahre dann mehr im Vertrieb, weil ich meine Erfahrungen da einfach im Sales weitergeben wollte. Kurzer Überblick, also eine ganz erkleckliche Nummer von Firmen und mittlerweile Immersive Engineering im Thema. Ich bin bei der Firma AeroFEM, da gehen wir ganz schnell durch. Wir sind ein typisches KMU aus der Schweiz, 23 plus X Mitarbeiter, schwankt immer so ein bisschen. Wir haben aber eine relativ kleine Fluktuation. Wir sind zu Hause im Aerospace, da kommen wir nämlich her und haben aber mittlerweile noch ganz andere Domänen jetzt erschlossen mit Simulation. Services Structural ist so das Hauptstandbein, dann mittlerweile CFD, Testing, Software Development, also wir sind da ganz breit aufgestellt. Und hier kurz zum Approach. Wir verwenden im Moment SimCenter für das Ganze, weil wir auch im PLM sehr aktiv sind und ich denke, das ist auch heute entscheidend, dass man da gut aufgestellt ist, dass man den digitalen Bogen komplett abbildet und möglichst seamless, also ohne irgendwelche störenden Interfaces und die Software, mit der wir arbeiten, sind hier mal gehighlightet. Das ist unser Kundenstamm und ja, Schweiz, wer kennt sie nicht, die Staumeldung, die mittlerweile Kultstatus hat. Und wenn man da so steht, kann man leicht sein Ziel aus dem Auge verlieren. Und da sind wir beim Thema. Der Weg ist das Ziel, KMU in der digitalen Transformation. Und da kann es durchaus sein, dass so ein KMU mal so eine Schleifenkonstruktion wie hier der alte Gotthard durchlaufen muss, bis er irgendwann mal am Ziel ist. Aber wichtig, der Weg ist das Ziel und da sind wir mal am Überblick, was ist ein KMU? KMU sind wirklich das Rückgrat sowohl in der Schweiz als auch in Deutschland von der Wirtschaft. Das ist der überwiegende Anteil aller Unternehmen und die sind ein wichtiger Beschäftigungsmotor und auch ein Innovationsmotor. Auch wenn es manchmal ein bisschen zäh ist, aber auf jeden Fall Rückgrat der Wirtschaft. Und ich habe hier mal so ein bisschen aufgestellt, es ist spannend zu sehen, 99%, also größer 99% in Deutschland sind KMUs. Das ist ein ganz wesentlicher Bestandteil unserer Wirtschaft. In der Schweiz ist es sogar noch höher, da sind es 99,7, wobei in der Schweiz sind dann die ganz kleinen, also im Bereich kleiner 10 Mitarbeiter und auch von Umsätzen her nicht so erklecklich, aber in der Summe ist es ein Wirtschaftsfaktor, den man in dem Zusammenhang einfach nicht unterschätzen darf und den es sich lohnt, weil dort sitzt die Innovation und wenn wir denen bei der Innovation helfen, weil die tun sich wirklich ein bisschen schwer damit, von der Investition, da kommen wir nachher gleich dazu, dann haben wir hier einen großen Anteil schon mal geschafft und ich möchte da nicht lange dran verweilen, weil es geht um ein Projekt und hier nochmal ein paar Zahlen. Und die sind also schon überzeugend. Ja. Und von daher haben wir uns gesagt, als Know-how-Träger, wir haben ein sehr großes Wissen jetzt in der Simulation, FE und CFD und im ganzen Zusammenhang mit PLM sind wir sozusagen ein kompetenter Partner, der diesen KMUs helfen kann, um ihren Weg in die digitale Transformation zu gehen. Das Dilemma, das wir haben, ist auf der einen Seite die Kompetenz. Ja, viele Firmen haben da einen gewaltigen Nachholbedarf. Und zwar, wir haben komplexe Simulationstools, mit denen wir uns da auseinandersetzen müssen. Wir haben Software und Hardware, die dann auch entsprechend komplex wird. Und wir haben qualifizierte Mitarbeiter. Das Ganze resultiert natürlich in Investitionen, die so ein KMU nicht unbedingt jetzt so schultern kann, um das aus der Portokasse zu bezahlen. Die leistungsfähige Software ist nicht ganz billig. Die qualifizierten Mitarbeiter sind nicht immer und überall zu haben und werden immer rarer. Und da müssen wir echt was tun. Deshalb sind wir auch im akademischen Bereich, weil dort müssen wir ansetzen, eigentlich schon viel früher, nämlich wenn die jungen Leute sich entscheiden, was mache ich denn? Ja, und da sind wir auch dran, Überzeugungsarbeit zu leisten im Schulumfeld. Und dann kam jetzt in dieser Geschichte der Anruf von Andreas Wierse. Hey Leute, es gibt da FF4 Euro HPC. Das ist ein Projekt, in dem man Forschungsmittel beantragen kann. Und wir haben 2 kompetente Firmen im Dienstleistungsbereich, auch die TK Consult, ein KMU mit um die 30 Leute. Wir haben 2 spannende Projekte aus dem Abwasserbereich. Wir haben 2 Anwender, die von diesen Entwicklungen, die wir da angehen wollten und angegangen sind, profitieren. Elkuch Group und Holinger sind beide in der Wasseraufbereitung mit drin. Holinger ist noch viel größer, die machen noch viel mehr. Aber Elkuch ist hauptsächlich im Abfallbusiness, in der Wasserreinigung. Und wir hatten 2 kräftige Unterstützer, nämlich die SICOS und das HLRS. Und da ist es auch unser Anliegen, um einfach Rechenkapazität zu vermitteln, haben wir gesagt, okay, dann schauen wir, dass diese Unternehmen jetzt auch Zugang hier zum HLRS kriegen und dort günstig und powerful rechnen können. Die SICOS hat uns gewaltig unterstützt beim Antrag, weil es ein Antrag ist, kann ich Ihnen sagen, ist jetzt nicht ganz so mal schön aus dem Ärmel zu schütteln. Wir haben dann letztendlich gewonnen mit 2 anspruchsvollen Technologien in der Wasserreinigung. Das eine ist die Ozonung. Man sieht, es ist ein relativ überschaubares Modell. Ozonung ist hauptsächlich dort im Einsatz, wo es um pharmazeutische Rückstände geht, in Abwässern, überhaupt im Wasser, weil man ja immer häufiger inzwischen pharmazeutische Rückstände nachweist. Ist dann auch gerade mit der Resistenz bei Antibiotika ein Riesenthema. Und diese Technologie muss per Gesetz in zusätzlichen Stufen in der Abwasserreinigung jetzt eingeführt werden, muss realisiert werden. Das heißt, da gibt es einen Markt, den man für diese KMUs erschließen kann, wenn man sie mit der richtigen Technologie ausstattet, wenn man sie mit den richtigen Rechenkapazitäten, Rechnerressourcen ausstattet, dass sie diese Projekte möglichst effizient abwickeln können. Das zweite ist die sogenannte Druckentspannungsflotation. Da sind wir in einem ähnlichen Dilemma. Mikroplastik ist ein Riesenthema, ja, es nimmt immer zu, es ist mittlerweile sogar in der Arktis, in der Antarktis nachgewiesen. Ja, also wir haben überall Mikroplastikrückstände und ich denke mal, wir sind da erst am Anfang. Die Lawine von diesen Mikroplastikrückständen im Wasser und überhaupt in der ganzen Umwelt wird uns noch sehr beschäftigen. Dieses Thema ist hauptsächlich für Großküchen, Gastronomie, die auch neue Reinigungsverfahren einsetzen müssen, um eben Partikel aus dem Abwasser rauszuholen. Und das habe ich jetzt hier nicht dazu geschrieben, weil da sind wir jetzt dran. Es ist auch für Reinigungsverfahren überhaupt vom Wasser sehr notwendig, dass wir diese Mikroplastikrückstände einfach rauskriegen. Wir haben 2 digitale Prototypen entwickelt. Einen die Firma AeroFEM, einen die Firma TK Consult. Und dazu ist zu sagen, ich verwende immer digitaler Prototyp. Es gibt ja Digital Twin. Ne? Ich nehme immer digitaler Prototyp, weil es ist eigentlich ein Prototyp. Es ist jetzt zwar ein Abbild, aber Digital Twin ist gut, ist in aller Munde. Ich sage immer noch digitale Prototypen. Und man sieht hier, wir haben einmal den Ozonreaktor abgebildet. Das geometrische Modell ist sehr überschaubar, also da haben wir nicht sehr viel Komplexität in der Geometrie weil geometrische Aufbereitung ist ja für die Simulation immer noch so ein zeitaufwendiger Arbeitsbereich, aber da sind wir schon sehr, sehr schnell geworden. Dafür hat es die Chemie in sich, das heißt, ich muss mein Simulationsmodell entsprechend bestücken mit Modulen, wo ich die Chemie rechnen kann, wo ich die chemische Reaktion rechnen kann, wie sich das Ozon in diesem Reaktor verteilt und wie das Ozon letztendlich auch mit den pharmazeutischen Rückständen reagiert. Bei der Druckentspannungsflotation, da war es ein bisschen heikler mit dem Modell, aber mittlerweile, wie gesagt, die CAD-Tools sind immer besser und wir kriegen die Modelle mittlerweile ziemlich lückenlos. Das heißt, bei der Simulation müssen wir immer drauf gucken, besonders bei der Strömungssimulation, dass die Modelle keine Löcher haben. Und von daher haben wir das auch ganz gut im Griff. Da war das Volume of Fluid als Basismodellierung und dann eben als Herausforderung, wie verbinden sich die Mikropartikel mit den eingespritzten, sehr fein verteilten Luftbläschen. Also Druckentspannungsflotation ist das Einspritzen von Luft in einen Reaktor, in einen Behälter und diese feinen Luftbläschen bilden dann noch feinere, eine Konglomeration mit den Partikeln, die in diesem Reaktor drin sind. Das heißt, die Luftpartikel binden sich an die Mikroplastikpartikel. Das Ganze wird dann aufgeschwemmt mit dem Auftrieb nach oben, kann oben als Schaum abgeschöpft werden. Das Ganze bietet sich jetzt an, weil jetzt kommen wir zu den HPC Top Values. Es sind komplexe numerische Simulationsverfahren, die wir da haben. Die Skalierbarkeit und die Optimierung ist ein Thema. Das heißt, man muss hier Parameterstudien fahren, man muss Sensitivitätsanalysen machen, wenn die Simulation läuft. Und XR- und KI-Technologie und Zeit- und Kosteneffizienz. Innerhalb vom nächsten Jahrzehnt, das ist jetzt der Business Case, werden Zehntausende kommunale industrielle Kläranlagen modernisiert werden. Und wir haben ein Investitionsbudget von 2,7 bis 3,7 Milliarden pro Jahr. Und das macht das Ganze zu einem Business Case, der wirklich hier interessant wird. Ich habe jetzt hier noch 2 Animationen mit reingenommen. Wir haben jetzt also für beide Technologien ein sogenanntes Template. Und das macht es für die KMUs leichter, hier effizient die Dinge zu entwickeln, zu optimieren. Die haben nicht mehr lange Wege, die nehmen das Template und müssen praktisch nur noch die Parameter, entweder die geometrischen oder die physikalischen Parameter ändern, können das Ding dann Fire and Forget auf ein Cluster schmeißen, hier am HLRS zum Beispiel, und haben dann innerhalb kürzester Zeit über Nacht die Ergebnisse. Ich habe das hier nochmal dargestellt in der Animation für die Druckentspannungsflotation. Keine Simulation ohne Validierung, ganz klar. Wir können ohne Experiment nicht leben, weil wir müssen die Modelle, die wir in der Numerik einsetzen, müssen wir dementsprechend validieren. Und man sieht hier sehr schön, hätte man eigentlich nicht erwartet, hier außen fließt es in der Richtung, ja, und gibt dann einen Counterflow in der zweiten Spiralwindung. Und das sieht man auch hier. Hier fließt es außen in der ersten Spiralwindung und in der zweiten Spiralwindung kommt es dann hier wieder zurück. Das ist natürlich jetzt nur mal der Charakter der Strömung, aber wir haben es auch mit Geschwindigkeiten und mit Drücken verglichen. Das heißt, wir validieren die Modelle, bevor wir sie dann einsetzen, entsprechend. Und gerade wenn man so ein Template macht, ist es natürlich extrem wichtig, dass das Template auch das liefert, was man sich vorstellt. So, und dann bin ich 45. Nomen est Omen, Schnelldurchgang. Vielen Dank für die Aufmerksamkeit und gerne Fragen.
Genau, du hast den Punkt getroffen, also von daher wunderbar. Gibt es Fragen an den Herrn Schnell?
Punktlandung.
Ja, Ralf.
Also wir arbeiten.
Ich wiederhole die Frage kurz für unsere auf dem Stream.
Genau, mit welchen Tools arbeiten wir? Genau. Wir arbeiten also im FE-Bereich mit FIMAP, mit Nastran. Wir arbeiten im CFD-Bereich mit Start CCM Plus. Und ich bin mittlerweile ja, seit 89 im Start CD, Start C10 Plus Doing. Und es ist einfach eine Software, die alles im Grunde bereitstellt, was wir heute brauchen, von der Schnittstelle zu VR. Ja, wir können also mittlerweile VR rausschreiben, können das dann in der Brille gleich anschauen. Also AI Immersive machen wir jetzt gerade. Das heißt, es wird praktisch am Schreibtisch diskutiert. Das Modell steht auf dem Schreibtisch virtuell. Jeder hat sein Headset auf und kann sich das anschauen. Wir sind aber auch im anderen Bereich, also wir haben auch eigene Software, Garros zum Beispiel, also hauptsächlich nichtlineare, dynamische, statische Simulationen im Flugzeugbau natürlich essentiell.
Gut. Gibt es weitere Fragen? Mir ist da noch was aufgefallen. Du hast ja erzählt, ihr baut diese Templates,
ja,
die dann andere benutzen können.
Genau.
Früher kamen die alle zu euch und habt gesagt, macht uns mal die Rechnung.
So ist es.
Und jetzt gibt ihr denen nur noch ein Template. Das heißt, ihr sabotiert euer eigenes Geschäftsmodell.
Nein, das war natürlich auch unsere Denke. Ja. Wir wollten ja natürlich jetzt nicht unser eigenes Geschäftsmodell sabotieren, aber wir haben durch diese Philosophie haben wir sozusagen den Markt erweitert. Ja. Wir haben jetzt Kunden, die früher mit Simulation gar nichts zu tun hatten. Ja, die haben gesagt, ja, was brauche ich? Simulation ist, man hat ja gesagt, CFD zum Beispiel ist Chinese Fluid Dynamics, ja, weil Colors for Directors natürlich abwertend, aber Chinese Fluid Mechanics, weil es eben sehr komplex ist. Und dadurch, dass wir jetzt den KMUs eben diesen Zugang ermöglichen, zu komplexen Strömungsberechnungsprogrammen, komplexe FE-Programme, erweitert sich natürlich der Markt. Ja, und dadurch, dass wir haben jetzt praktisch Kunden, die weniger bei uns in Auftrag geben, aber dafür haben wir mehr Kunden, die eben solche Templates beauftragen und uns dann die Dienstleistung abrufen, die wir da anbieten. Und von daher ist es eher ein Wachstum gewesen, als dass wir uns selber sabotiert haben. Ja.
Da könnte man tatsächlich auch so einen Template-Katalog irgendwie mal aufbauen, oder? Für verschiedene, weil wir haben ja auch, kommen wir später noch dazu, wir haben ja unsere Euro-CC-Projekte, da gibt es auch einen Service-Katalog, aber so ein Template-Katalog klingt durchaus,
ja,
sollten wir mal drüber reden.
Ja, also auf jeden Fall. Ja. Wir sind jetzt auch in die Medizintechnik eingestiegen. Ja, ja, ist gerade nicht schön, aber meine Frau hatte eine Mitralklappenoperation. Und mittlerweile simulieren wir auch Mitralklappen.
Jetzt im Nachhinein?
Ja, im Nachhinein, weil ich habe dann gleich im Anschluss an die Operation, als sie dann entlassen wurde, habe ich mit dem Professor dann gleich ein Projektmeeting gemacht und habe gesagt, wo hakt es denn da? Und das ist auch ein Approach, den ich eigentlich bloß empfehlen kann. Überall, wo es Ideen gibt, Visionen, gleich nachhaken. Ja, und immer gleich nachhaken, fragen, was gibt es da zu simulieren und wie können wir euch da helfen? Und so sind wir aufgestellt.
Gibt es noch weitere Fragen? Ich weiß gar nicht, können die Leute im Stream auch Fragen stellen? Genau. Du hast das im Blick, Karin, oder? Okay, gut. Ja, genauso schnell und passend, wie du deinen Vortrag gemacht hast, hast du auch alle Fragen beantwortet. Also von daher nochmal einen ganz herzlichen Applaus und damit du nicht
zumindest die wenigen
auf dem Weg in die Schweiz verhungerst. Ich hoffe, du musst dafür jetzt keinen Einfuhrumsatzsteuer oder sowas bezahlen. Aber also wenn du die nicht alle selber, man kann das durch 23 teilen, dann freuen die sich auch alle.
Das ist super. Die kann ja an der Firma aufstellen.
Ja, oder daheim.
Okay, wunderbar. Also, vielen Dank.
Vielen Dank.
Dankeschön.
So. Genau, also das Handover funktioniert schon mal. Genau, unser nächster Sprecher ist der Andreas Arnegger, den ich auch schon eine Weile kenne, nicht ganz so lange wie den Erwin, aber doch auch schon eine ganze Weile. Und von der Firma OSORA Medical. Ich weiß nicht, ob du ein Mikro haben willst, ein Handmikro, oder du kannst auch hier sprechen, wie du willst. Okay, du wirst verkabelt, genau. Genau. Bei dir, du hast ja sehr viel mit OSORA Medical, da steckst du ja auch schon im Namen. Du hattest auch gesagt, ihr guckt auch gerade Medizintechnik. Ich habe das Gefühl, dass das der ein oder andere hinschaut, Andreas ist quasi schon da ist schon bei der Firmengründung der Bezug dabei. Und da geht es um HPC-gestützte Therapieplanung bei der Versorgung von Knochenbrüchen. Ich weiß nicht, hast du auch mal mit einem Professor gesprochen, um auf die Idee zu kommen nach einer Operation oder?
Also ich muss sagen, ich bin von der Ausbildung her Wirtschaftswissenschaftler
und
ich fahre sehr gerne Mountainbike, aber nicht so gut.
Okay.
Und deshalb ist die eine oder andere Radiusfraktur hat mich vor 5 Jahren an der Uni Ulm, hat mich die Technologie gecatcht und daraus ist ein Startup entstanden.
Okay, also ihr seht, also hier passieren spannende Sachen. Und ja, jetzt bin ich auch ganz gespannt auf deinen Vortrag. Du sprichst Deutsch, ne, zum englischen Text?
Wenn jemand, if someone wants to or needs to hear it in English, I can also switch, or German.
English is better for me.
Then I stick with English.
But you should ask now if there's somebody who does not speak English at all. Then it would be, but hat niemand Probleme mit Englisch, dann darfst du gerne auch.
Then we stick to English. So Andreas already mentioned it. OSORA is all about broken bones. Our team is fascinated by the many possible and impossible ways people break their bones and what medical and technical capabilities are out there to help patients get back on their feet. Just a quick question into the audience. Who of you suffered from a broken bone before? There are a few, okay. Yes, okay. So the good news is when you're young, well, good news, that's the startup perspective. When you're young, you have a higher possibility, higher chances to have problems during bone healing. Why? Because you need to get back to work, you want to be active again, and then you tend to overload the healing bone. When we get older, we have a higher risk of bone fractures, and the bone healing is different than in young people. So what you see here is a digital twin of a femoral bone. You see also the femoral nail, the osteosynthesis product that's inserted into the femur, into the bone. We have the loadings where the muscles attach. And then in the middle, that bubble that you see forming, that's the OSORA core competence USP. We simulate bone healing. A bone heals better when it gets mechanically loaded, and we can show how that works. So, high performance computing and support in therapy planning. Why are we doing that? So, we are convinced that predictive analytics is an approach that is urgently needed in trauma and orthopedic care, since it's still a very eminence-based learning by doing discipline, and we think that the digitization of the workflow will help patients get back on track. The first step is the identifications of patients at risk. Together with 4 hospitals, we did a study on the early detection of non-healing. And the simulation already showed that we are better than experienced surgeons. And of course, for the patients, you want to spare them the suffering of healing complications. And for the industry partners, it's really important to filter the patients at risk early, because they cause 6 times higher treatment costs than normal patients. Secondly, we just showed this summer that we can use simulation to optimize rehabilitation planning, load bearing. So if the day after the surgery, if you can do full load bearing on the leg, or if you should go on crutches and do a partial weight bearing. This will help in the future to minimize treatment costs, faster ready to work, ready to play. And lastly, we think Herr Schnell called it the digital prototype. We think that the digital twin is a perfect vehicle for surgery planning because it's risk-free testing. You train off the patient and you can iterate a treatment approach without actually going to work on the patient or with the patient. And on the right side, you see our, well, I think it's last year's iteration of the user interface. So we use the digital twin to deliver quantification. On the top left, you see the expected bony consolidation, interfragmentary movement, and many more bone healing relevant metrics. And then on the right side, you see in white, this is the simulation of the tissue differentiation process and the healing bone. And on the right side, that looks familiar, it's finite element analysis of the implant loadings during the healing process. So that's the technology approach. How is a startup living off from this? We are very happy that we have first customers in medical associations that use the technology in an education tool. As in a train-the-trainer concept, this is, for us, was a big milestone because the medical instructors, experienced surgeons, use the tool to train the learning surgeons. So first time a non-engineering person uses the software tool to educate someone else. That was really a big step in usability for us. And we have full access to all users and all user experiences. We need to fulfill requirements in verification and validation. But on a regulatory side of things, that's much easier than jumping straight into the hospital. Then the second business case that we have is in silico engineering. We thought about, at first, we thought about using bone healing simulation as a tool for new product development. Turns out that manufacturers really like to reverse engineer a broken implant or a non-healing patient to see if it's the implant's fault, if the surgeon used perhaps the wrong approach, or if the patient was just not compliant during the treatment process. And all those learnings from those first two business cases that flow into our fracture management tool, we want to be in the patient-doctor relationship at the point of care. This will be a software as a medical device, a clinical decision support tool with its own requirements and its own regulatory roadmap. So, what is the challenge? At first, it's the digital twin generation. There's a lot of medical imaging that needs to be processed. We have the osteosynthesis data, material properties. We have patient data. We use AI to process the patient data that we cannot use with the simulation at the moment. And then we have load-bearing scenarios. We can then do simulation and iterate the treatment concept. We can use monitoring data from the healing process to feed the digital twin again, and so hopefully want to achieve optimal bone healing for the patients. And the use of high-performance computing, well, if you ask the engineers in our team, they would use high-performance computing just for the sake of it. That's the natural curiosity, but the use is, for us, it's driven by the business model. We offer OSORA as a simulation as a service model. And the first step of it is to have a feature-based pricing. So clinical users can just select the features that they really need. And so we can go from basic patient cases that compute faster to really complex scenarios with complex fracture patterns. Second, urgency matters. We have different use cases, elective surgery, where you have sometimes days of planning available, like hip replacement or knee replacement. That's usually a surgery that's prepared. And lastly, individual planning. Patients have comorbidities, they have biomechanical peculiarities, so we can scale the digital twin. So, and there the challenge arises. We started with the BW Uni cluster, since at the beginning we were a project team of Ulm University, so we had everything in place. And we were working with data from Ulm University Hospital. And when we took the next steps, working with more hospitals, we faced the question, how do we transfer the data? So, and then we went back to the workstation-based approach. We computed the data in the hospitals. We did the simulation even in the hospitals. That's pragmatic. You put the workstation in the car, drive to the hospital, work with the data, go home, and use the data. And thirdly, we used cloud services. That's for industry a big yes. They have usually the partners in place. For hospitals, that's rarely the case. So the last option is the dedicated high-performance computing. So with the first three options, we covered pre- and post-operative simulations of the fracture scenario. And in the last 5 years, we were able to really bring down the simulation times from 2 days to 2 hours, which is very nice, which helps a lot in the workflow because you can do, first time you can do overnight services. But the goal of the simulation, and that's what the clinicians want, is to use it intraoperatively. Before you close the patient, you want to know if that bone heals or not. So, we are currently developing a novel concept for clinical decision support where we can optimize the level of clinical decision support and the precision of the simulation, model complexity, and simulation speed. With increasing predictive performance, we can go, as mentioned, from elective surgery to emergency care. Emergency care is the motorcycle rider that leaves the road, or the grandma that crashes down the stairs. These are cases that are currently mostly treated with clinicians' experience, and the planning approach and the rehabilitation planning approach is here of great value for the clinical practice. You see here also another mock-up of a user interface. The clinicians don't really care about if it's AI, simulation, high-performance computing, or a workstation. They care about verification and validation because the simulation results must be safe and they must be precise and they must ideally also help the patient. And with better predictive performance, we can cover more implant bone configurations and more load-bearing scenarios. With more computational speed, we could improve the workflow more. We could iterate faster the model generation. And I would emphasize also the last point, the risk-free and live testing. Currently, we have risk-free testing, but not live testing. For surgeons, it's really important to know if one screw more or less in the implant really does change the bone healing process. Or if you want to bend the blade a little bit to make it anatomically better fit, how does that work then also for the healing process? Lastly, we want to work on the model complexity. We want to scale between low and high fidelity digital twins, which is really a matter of performance. And also we need to adjust that to the clinical decisions that have to be made. We want to use adaptive meshing, and then also we can push for more efficiency in image processing. Image processing is like one of the biggest cost factors that we have in digital twin generation, and we have some ideas and concepts in place how we bring that down, but that's a matter for the next steps. So, the summary, we want to enable safe and effective use of digital twins. Usually we are very pragmatic. There are regulatory challenges with the concept of modeling and simulation in health. We are heavily leaning towards the US FDA regulation for that because we have more guidelines, but safe and then effective use, that's the priorities. And we always have that user-driven product development, that it's decision-making in high-stress environments, usually under pressure. So we built the concept, we have the concept for clinical decision support. We want to use high-performance computing in the next step. And the benefit is, this is the foundation for our user interface and the clinical workflow integration that hopefully helps to lessen the burden in the clinical workload. And with more computing power, we can use more patient data like comorbidities, obesity, diabetes for the bone healing prediction. So our call to action, no startup presentation without call to action. We we are experts in bone healing simulations, but we benefit a lot from the exchange and know-how transfer and how to speed up simulations, how to achieve that 80-20 solution and not over-engineer it. And for the concept implementation, we also just submitted the application for the Invest BW program, where we hopefully can start partnering here in the ecosystem and push the technology forward. Thank you very much, and I'm really looking forward to your questions.
So, yes, well, Erwin, please, you're Schnell.
So bones are very inhomogeneous. Bones are very inhomogeneous. Where do you get the correct structure and the material data? Okay, the structure you get probably from the CT. But how do you model the material data?
Yes, I just go to the first slide, I think that. So what you see here, that's an idealized version of the bone, where we have basically two bone material properties, the shaft, and then also the joint regions. Here, that's pretty easy, but it's also a clinical question, like if you how you want to model the bone. For the surgeon, the important question is, does my screw hold in the bone? Yeah, and depends. We can use biplanary X-rays, which is very poor on bone quality information. And then we can use 3D CT data where we have a lot more information, a lot more detail about bone quality, yes.
One more? I was at Additive Manufacturing and MedTech in Lucerne. That's a combined fair. And I was surprised that a professor from the University of Basel, from the University Hospital, he was giving a presentation on additive manufacturing in face surgery. So is this something you're interested in, additive manufacturing in terms of bone healing?
Yes, the additive manufacturing technology is very interesting for everything that's visible, like face and head. It's also very viable in the hip and the pelvis, for pelvis fractures, because there's a lot of customization going on, and you always need to plan those surgeries. You have the duty to plan them. So these are the first use cases where you can really scale the technology because there's so much money behind it. Yeah.
Okay, I think there was another question. Yes.
Hi, thank you for the presentation. It was really interesting. I actually have two questions, but I will start with one, I guess. So you said the whole is the startup company, right?
Yes.
So are there already like confident data that provides information how confident the simulations are, or is this just something that you have to see during the startup process?
Yeah. So we have a process that is leaning heavily towards the ASME VNB40 guidelines, and we are very transparent about that. Our basic mechanistic model comes from animal testing, so we always have that in the core, and now we are working on training the algorithms with human data. So we always need to explain what's possible with the simulation results, and more important, what's not possible. So we have that very clear always in the backlog of the simulations.
So you also make it clear for the surgeon that like final decision is his. Like he can use the data, but it's his decision if he trusts the data enough to make his decision. Okay.
Usually for the surgeons, these are colored pictures where he works on. So we always want and need to explain it because we need to know how high is the threshold for explainability that we need to really fulfill.
So it's also like a process to get the public and also the surgeons to get the belief that this data will be confident in the future because it needs training. Okay.
Yeah.
And my second question is, you said that during the healing process, during the rehabilitation process, there will be new data provided to check if the simulation holds. How will this be provided, with X-rays or CTs? So you will have to do more CTs of the patients. This is a question just in my interest, if you have considered this, if you want to reduce workload in hospitals, but at the same time, more or less multiply the amount of times patients will be sent to CTs or X-rays. If this will at least level at some point the effort a hospital has to do, or the staff it has to invest?
For the current studies, we used radiological data for the healing milestones. We are working with experimental data, for example, from Tübingen. They use more tracking devices like smartwatches to measure the amount of steps taken per day. And these numbers are proxies that we use for bone healing evaluation. Yeah.
Okay, thank you very much.
And there are tons more from variables, data from variables that could be fed into our system. Yeah.
Okay, thank you very much.
So we probably have time for one quick question, please.
Thank you for the presentation. I would like to ask about that. You are only focusing on the bone healing for the in case of the broken case, or for example, are you focusing on some special cases like scoliosis or such kind of things?
We are currently focusing on the lower extremities because of high failure rates. And also, we are most experienced with the biomechanics of the lower extremities. If it's a fractured bone or if it's an osteotomy, is a matter of data, but we are working on that. And our, or the clinician's wish is to then actually move up the functional chain, and then from the pelvis move up the spine. That is our roadmap, the road ahead, yeah. But currently it's mainly tibia and femoral fractures, yeah.
Okay, thanks a lot. Yeah. So again, some food for whoever.
I just hope there's another traffic jam on the way home.
So thank you, Andreas. So our next speaker, I also know, but only since about 1 hour. So Dr. Sebastian Meyer. Okay. Oh, sorry. Genau, aber persönlich jetzt, ganz frisch. Von der Property Expert GmbH, möchten Sie auch auf Englisch vorstellen oder lieber Deutsch, wie Sie sich wohler fühlen? Wenn es Ihnen egal ist und wenn keiner mit Englisch Probleme hatte, dann dürfen Sie gerne auf Englisch, aber Sie müssen nicht. Ja? Also von daher, ich kenne das auch, wenn man mal nach einem englischen Wort sucht und es fällt einem nicht ein, das Deutsche weiß man aber, dann einfach auch das Deutsche sagen. Ich glaube, das funktioniert auch mit dem Herrn. Von daher. Okay, I'll switch to English back again. So, which is easy. The title is English: Using Damage Images in AI-based invoice checking. So I Googled a little, and I know you're working with insurance companies. So I guess that's the case. Also, know you send a picture from the dent in your fender or whatever, and then they check whether this could really be an accident or whether you did it on your own. And so I think you are doing those things automatically AI-based, and we'll learn. Thank you. The floor is yours.
Yeah, thank you very much for having me here. So yeah, I think when I look at all the other talks, I fall a bit out of scope here because I'm not. At least our basic use case is rather bureaucratic and not so much technical. But of course, AI plays more and more a role in here, and what I want to do today is present some. So we also took part in this FF Plus innovation study, and I want to present some first early results we made there. So let me quickly first explain. Okay, what is our use case? And what you see here is a simplification of the reality, but this is the ideal goal-to picture where you want to end up. So say you have, we are in property damage. So say you have your house and there was a storm and now a glass is broken or something in your roof. I don't know, tiles have come up, whatever. And every one of you who ever had some property damage knows that nowadays this is usually the time that your insurance company or insurer reacts can be quite a while. Why? Because the process in the background, whether actually what has the repair measurements your craft company comes up with, whether they are legitimate, actually covered by the insurance or so, this is an involved checking process. But ideally, you want to have something like this. You just have your documents, your invoices, images of the damage, maybe some reports on what hours have been done on what, and you just want to upload them, and whether to the insurance company, and in an ideal world there will be in a very first step, or there will just be one AI black box that looks at the stuff. And when there are no anomalies, nothing looks wrong, nothing looks suspicious, all prices look okay, then the thing just goes directly back to you, and the payout is cleared. And if this is not the case, then certainly an expert has to look at this. I think this is some very important aspect of this use case. Though theoretically you could also automate the not okay case, I think for various legal reasons and also how we human beings, I mean, we want to have explanations. Often there's also stuff then that the data you have does not fully resolve the case, right? If saying something is not okay, it's just an indicator could also just be an indicator that certain data is missing, or you have to talk to the craft man to get some further information. So I think we can say the not okay case is always something where human experts will be involved in the process, but we can automate the okay part. And so essentially then the goal with the AI classification model you have before is to have a proper and sound distinction in a classification into okay, not okay, something you can rely on. And I mean, so what we already have models working in place productively, and they work quite nice on certain cases, namely then when all relevant information is text-based. So when it's basically enough to look at the invoice itself, and the case is it's such a case where this is enough to just look at this. But there are actually a lot of cases where visual clues from damage images is actually key. And I just give you one example here. So this is just an excerpt of an invoice, and you see some line items where it's been described what has been replaced and repaired. And actually, in this case here, the validity of this thing, whether these repair measurements were necessary and are covered according to the insurance policy, can only be finally assessed by looking at invoice the roller shutter images, because there I get the actual material information, or I see, does the material I have here fit to what I see in the line items? What is the general state of this thing, right? How old is it, so to say? And so linking visual clues or information about the object that has to be repaired with these line items is a clue for a lot of cases. And this is something which can nowadays actually not really be done. Even if you take the most powerful vision language models out there, so nothing we could ever develop as an SME, but if you take Gemini or OpenAI stuff, then you will see that as long as we talk about generic image text alignment, so the knowledge involved is something you could say is just world knowledge. So you have, for instance, you have to recognize that there's a chimney on your roof, and in the line item it says something about chimney. That works. If the linking is just about this general world knowledge, then we did some experiments on our stuff. If we restrict it to that, then you see that it's only a matter of which model version you use, so to say. The newer it is, the bigger it is, the better it works. And surprisingly, we saw that few-shotting it, so doing in-context learning, which means you do not really train your model, but you just use the large context you have with modern vision language models and put a couple of examples into the context and say, please look at these examples and then make your decision. Surprisingly, with the smaller models, this did not make any difference, but at least with the latest Gemini 2.5 Pro, there we saw improvements. But this is all just for generic image line text alignment. Once we really get to our domain, so we really start to look into the details, these things just completely fail. Meaning there is still really a lot of potential for having an own domain-specific multimodal invoice model. And so this was our goal in this FF Plus innovation study, that we want to improve on our purely text-based approach by making it handle images as well. So the first big challenge we have to address here is actually the data preparation. So goal is clear. We want to enable our foundation model to capture these in-depth relations between damage images and line items and invoices. We have a lot of images. We're in this area for more than 10 years, so we have more than 10 million claim images. But the problem is, we have not really labeled them. Or if you are, the more you think about it, it's also not really clear how to label them. Though when you talk about actually data preparation here, so their key considerations are, what kind of image text mapping do you actually need here to make this connection? And I can tell you the full answer is actually, labeling is even the wrong word here. You talk about a full decision graph between the image and the line items. We really try to reproduce what's going on in an expert's head when he or she is making these connections. So this is certainly out of scope to model this. So then the question is, how much granularity do you need? Then it's clear, actually labeling this, or the more perfect your labeling is supposed to be, the more expert knowledge you need to this, the more cost, the more effort you need to do this. And so in the end, it was clear for us we have to approach it from two ends. If we really want to get to a large-scale labeling, the labeling has to be at least semi-automatic or automatic, so it has to be simple so that you can do it in a large scale. And on the other side, you build a small-scale, high-quality data set, but where it's clear that we can only get it to a size that you can use it for validation, or maybe for making a bigger model smarter so that you can use it then for labeling, something like this. And so the fine-grained approach really meant that we had to develop a very sophisticated labeling tool where we, in the end, decided to capture the following. First of all, we need detailed information, what part of your building is really affected, so very, very fine-grained. Actually, if I look at most of the words, I don't really know what it is. It's like Wandanschlussband. Well, I could never done it myself. Then we need information on the state. Is it damaged? Is it not damaged? Or is it damaged but it's not related to the insured case? And we need this relation. Which line items are actually affected or not. But this is a simplification. This is not this is the thing we settled on. In this trade-off between how complex can it be, what our experts can label, and we still see a chance that we can plug or actually know how to make the AI learn on this. And the fine-grained the coarse approach is that you say, we have this gigantic database of images and we know how to find similar images. So let's solve this problem like this, that you say, I have my case image and I reduce this problem of linking it to a line item to something much simpler, namely by just letting the model learn in the first place, does this image belong to the case or not? And we give you hard negative examples that look very similar but do not belong to the case. And do you learn now? And then our hope is that in a big pre-training, that this thing actually starts to learn high details to make this distinction. Does it belong to the case or not? But this is something which we can easily scale up, the building of the data set. And how does now actually the model look like that we want to improve here? I mean, I would not even say that this kind of architecture is the go-to architecture, but it's the main reason why we have this architecture is because our text model has half of the first tranche. So you start with your PDF document. There's some separation into pages. You OCR them, you tokenize them, and then you do a text embedding. And now we simply want to add another pillar to this, where you have your images, use some pre-trained image encoder, and then on top of it, you put a multimodal transformer architecture, and then several downstream heads for classification. And go. We have first results on it. It was a lot of work to actually get this whole thing up and running. So these are really just first results. They are promising, but certainly not enough. Pre-training so far achieves 90% accuracy, which is good, but also when we look more into the details, I think the model still cheated a bit. So I think we have to do some redesigns in the way how we actually provide these hard negatives. And on the downstream task we're ultimately interested in, we achieve 4 performance point increasement, which is not a lot, but a first indication that generally this whole pipeline works or the whole idea works, and the model is principally capable, or it's a model of that size is enough for our small niche that we can actually learn these relationships. What is to come? It's clear images enhance invoice classification, but surely we need to improve here by making adjustments to the dataset design, the training strategy, and maybe even to the architecture. And if this all works, then certainly our first goal is that invoice classification becomes better, but we also hope that this, the foundation model is a backbone for us then to tackle a number of other image-centric applications that are interesting, like AI-based cash settlements. So where you really only look at images and can immediately say, what's the price I will give you? Before-after damage comparisons and damage prevention is also a topic which is becoming more and more important. So that's it. Thank you very much.
Yeah, vielen Dank. Thanks a lot. Are there any questions? Yes, please. Wait for the microphone, please. Yeah.
I want to understand, for example, how your system is avoiding, for example, such a scenario. Okay, I have an invoice, and then I took the picture, and then sending you. But I took the picture and then share it with the AI-based large language models so that to generate it based on to pass automatically the insurance company check.
Mm-hmm.
Such kind of violation. Mm-hmm. Is there any image checking guardrail prevention, such kind of thing?
I would actually advise you not to do this. You get into a lot of trouble. So we have deepfake models in place. So when stuff is handled through our processes, we check for features that indicate that deepfake methodology has been applied, and then this thing actually goes to the fraud department of the insurance company. And if it actually turns out that you fabricated this, so then yeah, they will come for you. But in reality, so where this is a huge topic is with consumer electronics and stuff like this. Yeah. So there you really have tons of examples where people simulate cracks into displays, etc. With property, we don't see it that much yet because there is, I mean, the whole setup around it is so involved that so far it seems not really to pay off, but it's also increasing. So we really have cases where people try to fabricate damages so that they could, yeah, get money. Yeah.
So, are there any other questions or in the chat or wherever? I was wondering actually, when I thought a little bit about what you do, you have the images, you have invoices, and you have a long list of already decided cases. Mm-hmm. Wouldn't it be just simple to throw everything to an AI and say, learn by yourself? And then, obviously, I guess it's not that easy, but why?
First of all, I mean, maybe that works, and but I think to do this, even the compute hours we got in FF Plus would not be enough. Mm-hmm. Second, I think maybe also the amount of data we're talking about here wouldn't be not enough to do it in this.
You have many different cases, and then
yes,
the samples are
and
too small,
also
yeah.
there's because there's a first thing that if you really start with nothing, there's a lot of images in cases which are actually not case related. Mm-hmm. So also so these documents, they usually. And a very important first step is to identify which information is not relevant at all. Mm-hmm. But I would not exclude that this would work if you had enough data, if you had enough compute and money. But for an SME, I think we still have to rely to some extent on you.
You need to be smart then.
Yes, we have to be smart.
Yes. Oh, there's one question, Karin. Yes.
Yeah, there's one question from the chat. Is labeling necessary here? Let the model explain what can be seen by focusing on damages and let another LLM model map this to the line items.
Yes, this is a very interesting question, and also in our research team we have two fronts. There's the young people who question all this bullshit like labeling, doing any work, actually thinking about anything. I'm an old guy. I learned all this old stuff. So honestly, I think we don't know where the truth is here, right? How far do we get? But as I said in the beginning, I mean, I showed these slides here. What you have to be aware of, letting the AI do everything, formulating the problem, criticizing it, that works as long as the, say, intrinsic know-how that's in your model is good enough. And we know that here, for a matter of fact, it's not. So meaning if you do this, then you would actually have a process where you have a couple of normal people who have no know-how about craftsmanship, how invoice processes look like, that they try to figure this out. That is what you would actually do. Yeah? And we know modern LLMs and VLMs, they don't have this ingenuity that human brains have. So, meaning this whole setup would only work if I had completely different numbers here. So if I would say the basic linking, VLMs could do them, then this whole idea, I guess, would take off. But otherwise, no.
Thank you.
Okay, thank you. For the sake of the coffee break, I'll finish here. But you are around anyway, so
yes.
Questions are welcome. And probably if you take this to the coffee break, many people will come try to.
Yes, I think I will bring this to the team.
That's a good idea, I guess. You're by car, right? I was just wondering
no,
if somebody
by
goes.
train.
A train is also fine.
Also
by the airport, I don't know what they do with this kind of.
Thank you very
thanks
much.
a lot, Sebastian, and let's have a break until 11. Wir sind zurück zur zweiten Runde. Anwendungsbeispiele aus der Industrie. Und wir haben jetzt die nächsten beiden Vorträge, sind tatsächlich online geschaltet. Ich sehe schon den Herrn Paul von Berg von der Urban Monkeys GmbH. Genau, Sie sehen den auch alle. Für Sie zur Info, Herr Berg, wir haben einen englischsprachigen Gast, der sich freut, wenn man Englisch spricht. Es gibt keinen von den Deutschen, der sich ärgert, wenn sie Englisch sprechen, aber sie müssen nicht. Aber nachdem Ihre Folien schon Englisch sind, vermute ich mal, ist das kein Problem. Er ist im Moment aber noch nicht da, von daher. Aber ich denke, fangen Sie dann gleich auf Englisch an. Also der Herr von Berg ist online geschaltet, weil Sie sitzen, glaube ich, in Berlin, wenn ich das richtig mitbekommen habe.
Ganz genau.
Und ja, ich habe schon mitbekommen, selbst eine S-Bahn Stuttgart hat mal eine halbe Stunde Verspätung, wenn man hier hinkommt. Also Anreise aus Berlin wäre schon eine größere Aktion gewesen. Deswegen freuen wir uns, dass Sie dabei sind, auf jeden Fall online. Und bei Ihnen geht es um Praxiserfahrung, Feintuning, Geospatial LLM und HPC. Und ich sehe schon Geospatial, ein Stadtplan, sieht nach Hamburg aus, oder? Ich weiß gar nicht. Ja,
ja genau.
Im Hintergrund. Und ich freue mich, and well, let's just switch to English if it's okay for you. And you have the stage. Everybody can see you here already. Please go. You don't see my watch, but we are starting now 11:05. So 15 minutes, if that's fine for the presentation. Then we have 5 minutes for questions. Please go ahead.
Yeah, absolutely. Yes, thank you so much. I hope everyone is relaxed after the coffee break, has the coffee with him or her. And we are talking today about geospatial AI. So I'm Paul. I'm the CTO of DataMonkey. I'm actually very happy to be here today in Stuttgart, even if it's virtually. As I'm born in Stuttgart, so always happy to be there, even though I'm calling in from Berlin. So what we are doing at DataMonkey is we are making AI understand the geospatial world around us. And I think it's a very important distinction today in our setup to what is AI. AI is like a huge bucket, and we are talking in AI in the sense of a large language model. So basically the hype that we had the last, I would say, 3 years. And we are like training specifically large language models to interact and to get information from the geospatial world. So I'm the CTO at DataMonkey, and DataMonkey, we are a startup here in Berlin, and focusing on how we can apply the technology of the geospatial of the large language models together with the geospatial world. And today I'm talking in the sense of like what would I like to have known 1 year ago when we started training our large language model on the HPC. So we are also supported as some other projects by the FF Plus program where we're taking part on, and this is giving us the ability, one on the hardware side, but also on the financial side to train our specific large language model. So in the first few slides, I will set a bit the scene, like what is the geospatial area, because I would say it's a data science niche. And then we go a bit in the lessons learned that we could take away from the training itself. So basically, let me set the scene by like what is geodata. And I think geodata is kind of interesting because it has two very interesting properties. It has the languages, right? As we humans are referencing to objects, to street addresses, to geographic regions like Stuttgart, or basically buildings. And so this is how we as humans interact with that, with the geospatial world. But obviously there's another side to it. And this is in the geo world, it's numbers, it's coordinates, right? So where is this specific location of an object? What is the distance between objects? What are the areas, basically the polygons in the geospatial world around specific regions? And obviously we have a time set up. So it's has like these two properties which make it very interesting to interact with. And we've seen large language models are very powerful when it comes to interacting with language. So That is already what we see today, but obviously the number side lacks. And so we set up to merge these two worlds, to match the numbers with the languages. And specifically, we are addressing with our product, with our company, the GIS scientists. So it's geospatial information system. So it's a very specific area of data science. And we are especially trying to solve the problem is like acquiring the right data, which is actually really hard to do for the data scientists, but also for novices, right? So if you're a business expert, but you would like to underlie a business decision based on geospatial data, it's basically impossible to do today. And we are trying to bridge this gap between the languages and number to enable these decision makers, also the data scientists, to take better decisions. And the approach how our application is working today is relatively straightforward, right? So we understand, or the large language model understands the user intent. Okay, what does the user want to accomplish? It's identifying the right areas. Where are we looking at? It's looking for the right data sources. So geodata is very spread, which is a challenge, but also an opportunity for the large language model, because the large language model understands the intent of the user, and then can identify the right data source, basically. Then once the right data source is identified, it needs to query this information from the right data source, needs to filter it and make it like accessible or addressing the specific user location or the specific user question. And then basically analyze it. It's the only part left. And this is actually like the full ETL pipeline, the extract, transform, load pipeline that we're enabling on the geospatial area. And this can be done in an application, like we have a front-end web application that everyone can use and can use for the analytics, but we can also supply it via an API which can be integrated into workflows. So for example, like address validation is a very typical example. Obviously, it's super important that if you want to ship something or want to send a technician, that a location can be referenced. And now, where's the complication, right? So why can't we not use like a generic large language model for it? And the reason for that is that there's specific nuances in the geospatial language. And I've added a picture here. It's basically on my daily commute, even though it's I have the picture from Wikipedia, but that was like more of a coincidence. So like, what is a cycleway? So I'm cycling to work every day. In the human language, I would say everyone has a clear understanding of like what is a cycleway. But in geospatial world, it has actually a lot of options. So in this image, we see, okay, this is a separate cycleway which is separate from the car infrastructure by specific bollards, which are separating it. And this gives us the challenge that there are actually thousands of options how cycleways can be classified or they can be segmented also in different areas, and depending on the question that you want to answer. So if you want to, for example, improve the cycle infrastructure, which honestly I would like, so that would be solve also some problems of the traffic jams that you have or had this morning. But the problem is now, okay, how to address it correctly. And this is a distinction that normal language models don't have, because it's not part of the human language how we interact today. So we want to provide like this specific knowledge to a large language model that it can query the specific geographic contents of it. And this is what we set out to as part of the FF Plus program, to train a specific large language model, or to be more concrete, to fine-tune a large language model, because we're not training a new one from scratch, but we're leveraging the general knowledge that the large language model already brings. And we use specific training data that we have in the sense of input-output pairs. So we have a human question, and we have the output. In our case, it is a specific querying language which we need for geospatial data. This is because we are querying a lot of the data from OpenStreetMap. It is like a super complicated, but the most complete data source that exists on geospatial data. And the way to interact with this data is like a specific query language, which has some challenges with regards to syntax and semantics of how this code needs to be written, or this query needs to be written to get the right content. So it's, I would say, a perfect use case to fine tuning because we have the language component together with like a specific semantic requirement. Yes, and this is basically what we set out to. And so maybe, or maybe we stay one step back. So we have a data set of 153,000 elements, input-output pairs, and 7,000 of them we have received initially from the University of Heidelberg. They've done some research and some studies beforehand, and we've used this as a data source to start with. But we quickly learned actually we need way more data. So we have created some synthetic data on our own. And this was actually also a huge part of this project, and it's making like the LLM training very hard. So let's talk a bit about now our experience and how we acquired the access, but also what infrastructure we chose and what lessons we can take from that. So the application itself was pretty straightforward. So there's an application available, or there was an application available at the time over the EU portal, and you could basically apply to this data intense application call. And this is like following a standard process. It's very straightforward, and it was then also granted the access on January this year. And we've chosen the Sinica Leonardo Booster HPC. So this is an HPC environment which is hosted in Italy or set up in Italy. And we've used that basically because we've checked that like what other projects or what similar projects are like already done on this environment to like avoid reinventing the wheel all of the time, right? And to make sure also like our application can work on this environment. And we've seen that there's an application, or there was an application that the EU has done, which is basically training a large language model on all of the European languages, right? So this is publicly known, and they've also like decided to advertise this. And so we know, okay, so the environment was suitable for our large language model training case. However, it turns out it's not so straightforward all of the time because you have specific hardware, right? It's not like going to a supermarket and buying some GPUs. And you have also like specific limitations like packages or CUDA versions available. And for our case, we were, I would say, relatively close to the physical infrastructure or to the physics of everything. And then it's very important to have the right technical setup for that. The environment itself is obviously huge, right? And is very suitable for training these large language models. However, even we have directly reached also some limitations. So, for example, we only had 1 terabyte of storage initially, and then it restricts you already in doing training the very large models. So we have settled to fine tune 70 billion Llama, so Llama 3.3. Which is provided by Meta, and it has the advantage that it's provided by open weights. So it's actually something that we as a startup can truly own, which is like very important for us. But then you encounter like all of these challenging problems, and some of them it's just like physics interfering with it, which makes it also super hard to troubleshoot. And then sometimes also just a rerun solves it, right? So it's just like a bit is flipped and then you crash. Happily or like luckily it didn't happen too often, but it's something also to prepare for, right? So like when you want to train a large language model on the HPC environment, it involves a lot of effort. It's just how it is. The training process itself, looking a bit at the time. So there are a lot of key decisions to be made. And I think especially when we look at the model and the architecture, super important. I mean, the large language space is super moving super fast. We have like yesterday even released a new OCR model from DeepSeek. So Sebastian, maybe that's something interesting for you, how text can be interpreted, and it's 10 times more efficient than previous models. Last Thursday, there was a new methodology provided by Anthropic, how large language models are like being provided with new skills. So there's like new stuff popping up all the time. So thinking about the architecture is like super important that you want to support. And there comes all of the fun stuff with it, like what are the legal restrictions, what are the interference costs, which is also super important, and also one of the reasons why we've decided to go with Llama 70 billion. Then we have obviously some challenges in the training frameworks. So what level of abstraction would you like? And we have started with basically a really good template from Llama. However, it didn't work out of the box. So we spent a ton of engineering on like selecting CUDA versions and other like packages which are on the HPC and cannot be changed. So to engineer around these limitations was a significant effort on our side. And then it comes down to like what are the right hyperparameters. And in total, we have done in this right over 100 runs. I checked it beforehand, and actually we did it over 250 runs in the last 10 months. So you just spend a lot of time on fine tuning and to improving incrementally. But in the end, so we are super happy that we have like done this training. So we have created this very unique data set, which is for our startup a big moat to compare to other companies. We have created our GeoLlama with like also significant improvements on the evaluations that we have seen. So we're super happy about that, and we've also enabling the business benefits that we as a startup obviously are trying to achieve. So we are reducing the data preparation time by the users, by the expert, by up to 95%. So it's actually a huge jump for us from a technical capability perspective. And in the end, also most of the geospatial technology is provided from the US, and so we're happy to like have something also in the EU to be capable of providing some insights in the also very specific and also critical infrastructure. So I will quickly talk about the limitations, just looking at our time that we have. So base model and architecture selections is like super important, and also to see what is actually running or the HPC able to carry out with. And there's like directly one recommendation. So there's the AI factories that have been or that are currently being established, which would make the life of a large language model training significantly easier. So if you decide to go for a fine tuning or training of a large language model, I would definitely look into those and see if you can leverage these capabilities. And then you have like several other challenges. One of the bigger ones actually for us was the internet access, which is limited on the HPC environment because of the security reasons. However, for fine-tuning a large language model, it's definitely advised because you can automatically do hyperparameter sweeps, which is like trying to solve this optimization problem of what the right hyperparameters are for your training case. So if I would do it again, I would definitely see how this internet access could be established in order to do this automatic sweeps, which we now had to do manually. And this is my last, I would say, slide, and I will only go over briefly looking at the time. I'm also happy to share the slides afterwards, so just feel free to write me a mail. So for one of the important things is how to evaluate this model. So we spent a significant amount of time to think about how we can evaluate this model in a useful manner, that we really see, okay, we're making progress and we're changing the right screws in order to improve the model. And I would say this is probably even like 30% of the effort or more to set up a good evaluation framework. So really think about how this evaluation can be done. Then on the data side, prepare to engineer a lot on the data. So we thought we had a good data standing initially, but we've seen that we can leverage much more synthetic data generation, and we've also leveraged large language models to create it, which was actually proving super valuable. So think about how you can like 10x or 100x your data set, even through like synthetic approaches. It's heavily recommended. Engineering, we've also talked about this already. Look at the AI factory. It might help you and spend a lot of, save a lot of your time. And on the result side, in the end, ask your question. So if you want to do a fine tuning, which might be super valuable, but you spend thousands of hours on it. There are other approaches like RAG systems or few shots supplementation in the prompt, which are also achieving like some good results. For our approach, I'm super happy that we could do that because it really showed some difference. But it is a lot of effort which is required in that engineering. In the end, it's not only me, but we have a team of 6 persons who are supporting us, and we've also had the Epicure team, which are like HPC experts, supporting us in the engineering to make sure, hey, that we are on the right track for the engineering and the training. So that's it. A quick overview. Maybe from a lessons learned perspective, look at the data. Without data, you are lost. Look at the AI and the HPC infrastructure that you want to use. Super important to make the right decisions there. And then, have some fun. It's an exciting topic, and yeah, it's great to be part of that. That's it from my side. Thank you so much for the attention, and happy to take questions or share some slides afterwards. You find my email on the slide. Just send me an email. Happy to have an exchange.
Paul. And if you don't note it but still need it, contact us. We'll then give you access to the slides. So thanks a lot, Paul.
Thank you.
So we have time for, let's say, one quick question. Is there any question for Paul? You know, you'll be here virtually probably a little bit, but I think not everybody has access to the team session. So, yes, Herr Bode. Wait for the microphone, please.
So thanks for the very nice talk. So my question is, you said you're very proud that you have like a EU-based owned model, let's say, but you're building up on Llama, which is obviously not a European property. So what are you thinking about this? Do you think that like having not European large language model that you can build up is a significant problem of the AI startup, let's say, domain? Or do you think, well, it is what it is, as long as the US model is open weight, we don't care?
Yeah, a super good question, honestly. So I think it's bad, right? So it would be good to have like foundational model providers which are relevant in the EU. I mean, we have one company which is like slightly relevant, but I think the magic is not happening in the EU right now, and this is bad from an autonomy standpoint. However, as long as it is open weight, we are also happy. I mean, we need to look a bit at the legal framework sometimes. We have some regulations in the EU as the Data Act, the AI Data Act, which we really need to look into and really need to care about to be like compliant. But generally, I would say it's fine to use US models as long as you can then like really own the source. Yeah, so I would say for our case, it was good. We spent a lot of time thinking about it. So I would say it's fine. And also looking at China, where also there are fantastic models available there. I think it's also very fair to consider them as long as you can host it on an own infrastructure. I would not advise hosting outside of the US. The EU in our case.
Okay, thank you. There was one other question, Juliana.
Yeah, hi, Juliana Nikersu from Forschungszentrum Informatik in Karlsruhe. Just a short question regarding to how the collaboration with the HPC Center went. How did you find them? How did you, because you mentioned on a slide that it's very important to have a good specific support on the side of the HPC. I'm curious to see how did you find them? How do you collaborate with them? Also in terms of what you just said, that it's very important to own the models.
Yeah. Also a great question. Thank you. So in the application, we have not only received the access to the HPC environment, but we are also fortunate enough to receive some support from the EPICO team, which are like HPC specialists. And I would advise, if you have not so much experience in it right now in the HPC environment, to like get some experts on it, because I was surprised in how much like basic fundamental physics are involved in that. It's not only like running a program, but it's really like also thinking about basic fundamental physics principles, and just like sometimes it's also bad luck. You just need to rerun it again and then you're happy and it works. So that was one thing. I would also advise to do some smaller initial training runs in preparation beforehand. There are also courses available for that, which are providing access relatively smooth. And the rest was also, I would say, smooth with regards to the Cinica team and also the HPC team. So basically, we can reach out to them if we have any questions or challenges, and they supported us very well. So one example was we needed more storage space, because the storage space that was provided in the general offering was not enough for our test case. And then we were also granted that space, and that was, super important. So that was well.
Sounds good. So working with your HPC centers is probably a little bit better than just using Amazon. So thanks a lot, Paul, for having you. And
thank you.
We'll switch to the next speaker, Daniel Gröger. He'll also be online. I hope he can hear me already. He's from the company Alitic. Well, it's all about the weather. I hope so. So he will talk about machine learning, weather prediction for short-term PV operations. I guess that's photovoltaic. An HPC case from FF+.
Yeah, thank you for the introduction. It would be really, I plan to be there, but as you can hear, I'm a bit sick. So I don't want to spread my bacteria or viruses to you, so I decided to stay at home. But yeah, very interesting talk so far. So yeah, now we are moving from geospatial LLMs to another subset of geospatial data and field, which is the meteorology and weather forecasting. Yeah, my company is Alitic, and in FF+, it's currently in progress, the project. We are actually 4 people actively working on it, besides some others helping us, but we are the main participants here from 2 companies. We are the business experiment holder and developing the model for an energy-related forecasting issue. I will explain later, but we in general do weather-impacted forecasting for energy processes, and Ventus does something similar. They're also a meteorologist and data scientist, but more focusing on numerical simulations for mobility applications. And Mr. Dr. Andreas Waldmann, who also has some numerical expert and has some experience in high-performance computing, helped us here to build up an AI weather model together with Andrew and Dr. Benedikt Schulz from our team. The problem is, I mean, everyone will know the energy transition, and I think most of you will know that the energy generation from wind power plants or solar PV panels are weather influenced or mainly driven by the weather. Yeah, when the wind blows, we will have a lot of electricity. When it's calm and maybe overcast, then we have not so much generation, and the spot market reacts on this. So the main driver for the prices for the intraday and day-ahead markets, mainly the weather. Yeah, so when we have a lot of sunshine and a lot of wind, the prices are negative even in the day-ahead, and we have high prices when it's calm and overcast. And on the other hand, we have the load. Yeah, we have also heat demand, which is weather impacted. We have electricity demand. So the whole energy world is facing issues with the weather, and the volatile generation is forces us to do predictions. So in the end, accurate forecasts are very essential for the energy transition and to match both worlds of load and demand with the generation we have. And our proposed model, I will get in detail later, will focus on short-term prediction. This is why the project called Nowcast AI. Nowcast is a specific forecast horizon in the meteorological field, where we look at what's observed now, and then we forecast the next couple of hours. And we have the grid operators who are facing this issue to maintain grid stability. And at the moment, you maybe heard about redispatch or curtailments. They are applied very often to don't overstress the electricity grid. So there is a lot of energy that can be used, but still produced or could be produced from the power plants, but it's the grid operator says, no, we need to stop this for this hours to prevent any interruptions in the energy supply. And on the other hand, we have here, we have the energy traders, or in Germany we say direct marketers, who are selling the electricity from the PV power plants, from the wind power plants on the market. And they also facing different issues with the volatile generation. So they need to know how, as accurate as possible, how much electricity will be produced in a given quarter-hourly time interval. And when they know this very well, they can reduce their balancing costs. So every participant in the energy market has his own balancing wallet, and they need to balance. Everything they have to sold has to be produced, and when there is a gap, they have to pay for this. These are the balancing costs. So we have energy supply that needs to be secured, and we have a more economic part where both worlds would benefit from a very accurate forecast of the short term here. And traditionally, there is the numerical weather prediction systems taking into account a lot of data. And I explained this here with this short image. So we have weather observations from land, we have weather radars, we have satellites, we have aircraft. There's a lot of different data, and at least 20 to 30% of each of the whole meteorological scientific community works on data assimilation. And data assimilation means bringing all this data into weather prediction. And what sounds very simple is very, very complex, because the weather model needs to take into account all the physical laws, and it's very difficult to understand how much energy and water, for example, is stored in a cloud. Yeah, we know it. Not accurate, but we know it in certain ways. And this is very, there's a huge complexity in, and we are, and this is why the meteorological society and scientific community is facing issues there, because it gets more and more complicated to tell the model, okay, this is how the current state of the atmosphere is looking like. And this is just another example to explain what's current issues with numerical weather predictions. This is the stomata from a leaf, and what's happening there? There's CO2 and oxygen will be exchanged with the atmosphere, and it's an atmospheric process. And this atmospheric process, we know a lot about them, and in detail, if we want to predict the atmosphere very, very, very accurate, we would have to include this into a weather model. But at the moment, numerical weather models running operationally with spatial resolution of 1 kilometer. So within this 1 kilometer, we have to aggregate and simplify every processes like these atmospheric processes across leaves. Yeah. So in the end, there's just a leaf area index for maintaining these processes. So we simplify a lot. Yeah. So because we are still not have enough computational power to predict all of these small processes here. And there comes the AI weather prediction now in. So for about 4 to 5 years now, this field is fast evolving. So, and why do we do this as a data scientist and a metrologist? We expect faster updates. I will have an example on the following slides how this these faster updates look like. Yeah, we can assimilate very simplified, so that the whole complexity of data assimilation can be vanished because the input data will just be provided to the model, and the model will learn from it, and hopefully the model will learn the physics, but we don't have to take into account physical constraints because yeah, we will let the model do the job. In the end, we expect high accuracy from such predictions. It's not very clear that it's at the moment possible for all weather variables and all horizons, but there are still good results. And in the end, if we have a good weather AI model, it's very simple to do some transfer prediction. So what looks like a weather forecasting model in the beginning can be a prediction model for PV or wind in the end. So we're directly building up, predicting the target measures we are interested in. So what's the difference here? So when you look to the left, we have numerical data, analysis, observation, and this is input and initial data for numerical weather prediction. This is still known and nothing different as we dealt with in the past, but now we have this also as trainings data for our AI models, and Google and Microsoft and big companies working on such stuff. And just let me explain this. This should be a short video, but I still forgot that it's a PDF, but I can open it right now for you. Just give me a moment.
So please keep your time in mind.
Yeah. Nevertheless, what can be seen would be, or what I wanted to show here is that we can do 15 days of numerical weather forecasting in just 30 seconds, and the other day example where there are numerical models, and they will be not ready with 1 day in this period of time. Our architecture to do this short-term weather model are observations from weather stations. We use satellite images, a lot of them. Yeah, they are very important for us. Our main input feature for our unit structure we used here. We have also a lot of weather radar data, as precipitation highly correlates to the clouds, and we have some additional background information from atmosphere and from digital elevation models, and we tune this model on weather observations, and in the end we have irradiance maps for this. In the end, we are still in the middle of the project. We started with the data acquisition. We mainly use the STAR file format, which chunks the geospatial data into smaller portions to make it more to better handle such data. We build up our stack on PyTorch and Lightning, and utilize MLflow for the MLOps and observation of the model runs. We were still limited to the to what's available on the HPC infrastructure. So we needed to migrate our data to the the HPC, and yeah, also received a lot of support from the Epicure team and also from Cineca during the onboarding. And we are at the moment here having first models, and our next step will be tuning these models, adding more data, and evaluate them. And we're also looking to a bigger project like the weather generator project, where a lot of similar to what previously mentioned with the AI factories, there's similar stuff happening in the weather and meteorological area, and we're still looking to this to make it easier to build up such models. But at the moment, we decided to build from scratch to also build up our own knowledge and experience with some models. Here we have some preliminary result from our model, where we have an actual irradiance map on the right and a forecasted one on the left. And we're still having issues with blurring out and stuff like that, but this will be hopefully solved within the next steps, where we add more data to tell the model more about what's happening in the weather. So I'm finished right now and looking forward to your questions. Thanks a lot.
Yeah, thank you, Daniel. So I already see a hand up, Herr Bode.
Yeah, thanks for the nice talk also. I have two questions, one more on the physical side and one more on the business side. So start with the physical side. So if I follow the latest publications about AI prediction for weather, then it works quite well in quite usual situations, but very bad for extreme situations. So how do you deal with this to make this always work in your case? And then the second follow-up question is, I mean, you already mentioned this, right? I mean, this is a very big topic. There are extremely big players like NVIDIA, like ECMWF, who kind of bring up like new models with a lot of manpower, let's say every 2 months. So what makes you confident as a startup to being able to compete with them, and what is your idea to make it better? Thanks.
First of all, the first question about the physical constraints with the extremes, I think cloud development doesn't have such extremes, so we don't have see extreme precipitation or stuff like that. So we're not really dealing with this. We have another topic where we have to deal with this, and it will be a hydrological forecasting model, and it will be challenging. I mean, for us, it's our main KPI is predicting the weather very good for the whole year. Yeah, and I mean, you are right. When we are good in extremes, we will have a benefit compared to others. But at the moment, we are not really taking this into account in detail. But it will be a topic in the future for us. And from the business side, at first, the value of of AI weather prediction is limited because it's not generating a whole new information. Yeah, we still have numerics providing weather forecast, and skill. When we talk about skill, so a model might be better. It's really different to when you look to the applications and where you have skill. In the end, these big names are not providing specific services, for example, for PV power plant operators. So they have the global view. They're presenting their models to show what's possible on their GPUs and on their cloud infrastructure. I think this is the idea behind this, and we try to. I think our goal is not to be better as Google, because it will be very difficult because there are so many people. But what we can do is similar to what DataMonkey is doing. We can take the existing know-how, the existing models, refine it to a specific use case, as I presented here for the PV, and generate a value in the specific use case. And this is what we are focusing on, to generate value on a specific use case.
Okay, we have another question from Sebastian.
Thank you for the very interesting talk. I have one question and one remark, or one insight, because I thought PyTorch Lightning on one of your slides. So we learned that PyTorch Lightning is actually not a very good library once you do training on multiple cores and nodes. So I would be interested, what were your experiences with that? Because we decided not to use PyTorch Lightning anymore. And the other question, the other question I have is, I'm really not an expert at all in this weather modeling and what AI can do. But my question would be, I mean, I know there is something like this protein folding, where we see examples where provably AI-based approaches really outperform knowledge-driven approaches, say. But what I was wondering here is, with these large-scale simulation, are these comparisons between AI approaches and classical approaches really fair in respect that they really look at all aspects where the classical data assimilation approaches are good at? Do they really look at all physical aspects, or just pick out a few and are therefore faster and better? Maybe you can comment on this.
So when you're ready to, when the model is trained, it's always faster to make predictions with an AI model. That's clear. So they are outperforming on that scale by magnitudes. Yeah. So you can do a weather prediction in just seconds, what take hours, and on a numerical side. But when you look to the metrics and to the forecast parameters, they are good on some metrics, but it's as I said, it's not very clear that there is a huge performance gain on every applications. They always look to 850 hectopascal temperature, so it's more or less 1,500 meters above us, and they evaluate against a reanalysis, so it's still numerical data that they evaluate against. And in the end, the customer who has a process that's weather related, he decided which solution fits the most. And I think post-processing of weather data is much more important to solve problems on the business side instead of having the most accurate forecast. I mean, this is our experience from doing heat demand forecasting or electricity load forecasting. The post-processing step and the transfer from weather into application world is more important. And on PyTorch Lightning, we still have some issues. We are currently in the phase to investigate performance improvements, and PyTorch Lightning will be one of the tools we will check up. So it could be possible that we will move it away in a couple of weeks. So thanks for the remark. We will take a closer look on this.
And probably exchange directly afterwards. So, sorry. Thank you, Daniel, and another applause for you.
Thanks.
And we now go back to reality, the real reality. I welcome Dr. Xin Liu from our partner Jülich Supercomputing Center in Siede. And well, you will have a dam break simulation and a German byte operation model, so HPC use cases in the public sector. I'm looking forward to it.
Yes, thank you, Andreas, for the introduction. So I'm here to share some experience of our dealing with public administration, because from our experience, public administration is a very challenging sector, mainly because it's hard to reach the correct people that is willing to start the collaboration with you. And when you do reach the correct people and start the project, there is quite a lot of constraints that may kill the project in the middle of the way. Like we actually have started some initial discussions with Cologne Fire Department and Bonn International Center of Conflicts, but in the middle there's like some constraints of data security stuff, and then unfortunately we have to stop. So here I will introduce you some ongoing projects that we have successfully initiated and seems very promising. So the first one is Duisburg dam break simulation. So this project is actually brought to us by a sister project. It's called CERSI, which was conducted here in HLRS. It's a project that aims to build computing structure for emergency situations like the COVID, or for in this case the dam break scenario. So it's a request from the Duisburg Fire Department that they want to do a simulation of dam bridge scenario in the city. So what is available is a flat map that shows the risk area. And what we want to get out of this is information in the case that dam really breaks and there is a flood crisis in the city, which area to be evacuated, and what's like the safe assembly and retreat area. And for example, the time scale of the flooding and the response time. Like in this in this case, we just make the match between CERSI and experts here in HLRS with doing this simulation with experts in Jülich Supercomputing Center. That we have a data simulation lab that is focuses on terrestrial system simulations. Flood simulation is a well-known modeling problem that it uses shallow water equations, which is a simplification of the general flow equations. And the code can be used for such simulation. It's OpenFOAM can achieve reasonable results, and our colleagues in GSA, who is in the data simulation lab of a terrestrial system, they work on a code called Sergai, which is a shallow water model that has a GPU capability and very good scalability. So in this project, the Sergai was used to simulate the outcome of such dam break. So you can see what's input data we have in such modeling is the in such simulation is a 3D building model, which is built up on the real city, the real outlet, the real layout of the city, and in here you can see some flood protecting structures, and yeah, and then you also have the water depths of the Rhine River. And the simulation is conducted in 2 phases. So the first phase is that the initial condition of the water that it flows in steady state, that is shown on the figure on the left. And then the second phase is when the water goes reaches the downstream area with all the barrier structures like the bridges or the underpass or buildings, etc. So yeah, this is the map to show the water flow. And the results, so you can see that's that's in the top left corner. This is this black circle is is where the dam is broken, and then the water just flow into the downstream residential area. So what is important to develop for the response, like for the firefighters, is that you have a map to show, to visualize such a disaster, to guide them in their first response mission. And yeah, this project is still ongoing, and for that we just mainly did the matchmaking job. And this is a new project that we recently started with the Federal Waterway Institute. So the Federal Waterway Institute wants to build a German-based operational model. So just like a brief introduction of the Federal Waterway Institute is a central consultancy provider for the Federal Ministry of Digital and Transport and the Federal Waterway and Shipping Administration. So they provide expertise in shipbuilding, ship management, hydraulic engineering, structural engineering, etc. So they operate and maintains the waterways in Deutschland. They locate in Hamburg. And basically what they want to do is to build a German-based operational model that can predict, let's say, 48 hours ahead of time the water level in German ports. Why is important? Because knowing the water level of German bays is important for you to plan and operate the ships, like the limitation on the draft, the time for loading and unloading, and some forecasting of the disasters of coastal flooding, etc. So what they already have in their house is a unstructured model, unstructured nonlinear model that is already quite efficient and robust to predict water level based on weather data and the measurement data that they have. The code is called untrimmed, but it is not GPU ready. So what we are working with them is to generate a one-pager GPU porting strategies for porting of such a code. Yeah, so that's how the German-based operation model works. So here you have the weather forecast data from DWD, and you have the measurements of the water level from the past time, and you have other parameters like the water salt level and the temperature, and then you use the operational model to predict the water level in different ports. Yeah, so basically here is a flow chart of how it works. So you input the weather data and the measurement data, and then you get the prediction. So what we are trying to, another aspect of this project, what we are trying to do is to have AI components integrated into the operational model to make it all more accurate. So right now we are just starting to try out the LSTM, and I don't have results to show yet. So it's an ongoing project that we are hoping to do it in the next few months. Yeah, thank you.
Thank you very much, Xin. So, are there any questions for Xin? No questions so far. So if I look at the German byte, that's, I guess, a very large area. Mm-hmm. And the models really have to be large. How much vertical layers do you have there, or what's?
So it's not like we are trying to predict things in all the ports. For example, we predict a thing in Cuxhaven, so one port, and then the other port is another station, so we do it separately. It's not like the whole area.
So you focus on a certain area.
Yeah.
Right. And we learned in the previous talks there's also AI sometimes in combination with HPC, with simulation, with emergence. Is that something you're also looking into?
I'm not quite sure, because right now we are just trying out the LSTM. I think there will definitely be something interesting if we combine the two things, but we are still exploring.
So that would be another project then?
Yeah, probably, because we have to fit into the time scale of a proof of concept project. Yeah.
Okay. Any new question in the meantime? Yes, Erich, please.
How big is the cells? The number of cells?
Oh, wait a second for the microphone, please.
How big is your model size? You're using Navier-Stokes, and so you do the flow simulation with open foam?
You mean the first dam break simulation? Or?
Yeah.
Okay, that I'm not so sure, because this open foam is actually conducted here in HLRS by Dr. Ralph Schneider's group. So yeah, I'm just getting off some of his results to show here. Yeah.
Okay, so if there's no other question, I'll hand you over the mini-meter for you, your team, your family, whoever.
Thank you very much.
And thanks a lot, Xin.
Yeah, thank you.
So, this brings us now to the speed dating introductory round. And as you have probably have seen, I'm actually the first speaker as well. So you'll meet me again in the afternoon in the speed dating as a certain expert. I'm not the AI guy, but I know a lot about what's going on around it. Yeah, I'll briefly present. We have now 6 slots, about 10 minutes, so I'll try to be quick and talk to you about SIDE, actually, supercomputing in Deutschland, in Germany. Just a brief look back, we have quite a good history here with HPC systems. So when you take the compute room tour, you will actually pass by this document here, this device, the Cray 2. Lothar Späth actually bought about, he ordered it 40 years ago. It was installed half a year later. And he already thought about the Mittelstand, the SMEs, and introduced 15 positions, or I'm not sure, but for consultants. But actually it was a little bit too early. It quite didn't work, but it's not his fault. It's the fault of the system. That was a vector computer. There was no commercial software. It was difficult to program. Even the numerical simulation guys had to get used to it. So, but I'm sorry, this helped us to go along. So sooner, 10 years later, we founded a joint venture between industry and the academia here in Stuttgart, and the company I'm heading, SICOS, has been founded now 14 years ago to be more specific on the SMEs, especially in the Baden-Württemberg area. But SIDE is not only Baden-Württemberg. SIDE is actually a team. You've just met Xin. She's also part of the SIDE team. She's from the Jülich Supercomputing Center. HLRS, of course, is involved. And also the Leibniz Rechenzentrum in Garching, LRZ. And those 3 actually are the head of supercomputing in Germany. They are teaming to be the Gauss Center for Supercomputing. And there are, of course, a lot of other big computing centers from the research area. There's also, of course, cooperation. So by working with SIDE, you actually have access to everything that's going on at state-of-the-art supercomputing in Germany. I guess I can be pretty quick on this. Why this means progress. I think you're all familiar with why we do numerical simulations. So those are a few industrial examples from turbine manufacturers, a gas turbine to be more efficient. And down in the middle is a combustion chamber of a power plant where measurements are somewhat limited, so simulation that works well is much better. Or we have the aerodynamics of a motorcycle. So those are industry examples. We just seen, actually, I have the animated version of the dam brake simulation, but there's also urban planning, so that's more related to the public administration. And of course, there's science. So those are turbulence, so a really detailed model that show how turbulence, well, try to understand how it works. Applied actually also to real world cases, but still with not with a business perspective, but with trying to understand what's going on to improve things, and of course later have impact on business, or how fusion reactors work, what electrons do inside that, or even from space structures, hydrological structures in cosmic environments. So you see on every level there are many interesting things going on and can be computed. So, but what actually now is SIDA? I've told you about the 4 partners we have in Germany here, but actually there's a bigger background. There's the EuroCC project funded by the EuroHPC. JU in Luxembourg, so that's basically for the European Commission, 50% there, 50% from the member states. We actually started in September 2020, the first phase, and we are now in the second phase, and we are already talking about the third phase, but there are some budget discussions, but you're familiar with that. We have actually 32 nations which are really involved, and the idea is to have in each of these nations something like SIDA. So SIDA is Supercomputing in Deutschland, so we were one of the 32 nations, and the idea is to establish similar structures in all these 32 countries, and you're able to count, so it's more than just the EU countries. There's like North Macedonia, Iceland, or Montenegro, Turkey is in there as well. So it's really a very wide project, which in turn helps us to understand each other better, to learn from each other. And that's something we would like to make also available to you. So there's the topics we have are HPC, of course, and AI. At least until now, the AI factories have been mentioned already. So in the next phase, focus will be on AI for the AI factories, but for HPC on EuroCC. But again, here in Stuttgart and as well as in Jülich, there will be AI factories. So if you talk to one of us, you'll get the information you need regardless of the topic. And I mentioned already we are building a network of national competence centers, and I won't go into the detail here. I think what's important is that we are talking here about universities, research institutes, and companies, and there's really also a target to improve competitiveness, to help you make your business better. You've seen many use cases, several use cases this morning, and many of them have been supported by FF for EuroHPC, which again is coming from the same area. So it's all related, and whatever you do, if you ask one of those people here, we should be able to help. What you exactly do, I also won't go into detail, but you see there's something like, where's my, oh, that's the wrong one, this is the right one. We have services to and interaction with industry and academia and public administration, but there's also training and skills development, and we are building up a service portfolio and competences in order to really be able to find the right partner that probably can help you to solve your problem. So, and what we did, well, we had the NCC Germany, and when we wanted to establish we looked for a domain. NCC Germany, well, it was already used. So if anybody of you is inside motorcycles, but we also thought NCC Germany is something, when you hear about it, it really doesn't ring a bell. So we had a long process, a long brainstorming process, but we think that supercomputing in Deutschland is pretty straightforward. So when you hear it, you understand what it means. And SIDE is something we are now establishing as a trademark. And there are, of course, there's the website. That was also very nice. Supercomputing.de was available. So we really have something you can easily keep in mind. So. Yeah, and so if you're going to attend the speed session today with, well, actually me, although the SIDE part will actually be covered by Murat, who's sitting there in the background, because I will have to step in for somebody else, but that will be, I'll explain that in a few minutes. So that's it from my side today, and I have to check now, I don't know, it's Sander or Cosima who's going to present now the FF Plus innovation funding for SMEs and startups. You need your pointer? You have, okay.
Gut, ich mache mich direkt mal unbeliebt, weil ich jetzt auf Deutsch vorstellen werde.
Kein Problem, alles gut.
Klar hätten wir es auch auf Englisch, aber jetzt die ganze Präsentation ist jetzt halt auch aufs deutsche Publikum ausgelegt. Ich bin Cosima Weyers und ich bin Projektmanagerin beim HLRS und für das Projekt unter anderem FF Plus, also Fortissimo Plus, zuständig. Ganz kurz möchte ich Ihnen das jetzt vorstellen. Wir schauen kurz auf die Geschichte der Fortissimo Projektreihe und deren Ansatz. Dann habe ich 2 Success Stories mitgebracht und dann gucken wir auf das FF Plus Projekt im Detail. Die Fortissimo Projektreihe ist im Jahr 2013 gestartet und wir sind mittlerweile in der 4. Projektphase. Fortissimo Plus ist im Jahr 2024 gestartet und Ziel ist es, europäische KMUs und Start-ups beim der Entwicklung ihrer Business Ideas zu unterstützen und ihnen Zugang zu den HPC-Ressourcen zu geben. Insgesamt hat die Projektreihe auch das Ziel, dass wir die Innovation und die Wettbewerbsfähigkeit in Europa erhalten und weiter fördern. Genau, der Ansatz von Fortissimo ist, dass wir sogenannte Experimente durchführen mit den KMUs, die durch den Einsatz von HPC dann ihre echten geschäftlichen Auswirkungen erzielen. Und der Großteil der Projektmittel fließt tatsächlich in die Experimente, die wir durch die Durchführung von sogenannten Open Calls, also offene Ausschreibungen, akquirieren. Die 3 Vorgängerprojektphasen, also Fortissimo, Fortissimo 2 und FF4 EuroHPC, haben insgesamt jetzt 121 Success Stories geführt, die wir mit Hilfe von 310 Partnern aus über 20 europäischen Ländern erstellen konnten. Dann kurz, wir haben ja schon einige von unseren aktuellen Subprojekten heute vorgestellt bekommen. Dann möchte ich 2 aus den Vorgängerprojekt FF4 vorstellen, ganz kurz. Das eine ging es um die Herzfrequenzmessung tausender Patienten in Echtzeit. Hier hat das Experiment HPC genutzt, um ihr maschinelles Lernmodell zu trainieren bzw. auch zu beschleunigen. Ziel war es hier die Verbesserung der Genauigkeit bei der Erkennung von Herzrhythmusstörungen. Business Benefits waren zusammenfassend, dass die Fehlerrate um 50% reduziert werden konnte. Und die Erhöhung der 90% Genauigkeit führte auch, dass das Produkt noch wettbewerbsfähiger wurde. Dann auch konnte die Effizienz um 25% erhöht worden und der Profit durch verringerte Kosten und der Daten- und Softwareverarbeitung ebenfalls. Genau, dann zum zweiten Beispiel, das ist aus dem Bereich der Aquakulturen, beziehungsweise geht es um die Verbesserung der Produktivität in diesem Bereich. Hier hat das Experiment HPC und KI genutzt, um Aquakulturbetrieben zu helfen, Schwankungen besser zu bewältigen. und damit ihre Produktivität zu steigern. Hier haben sie durch eine Datenanalyse dann zum Verhalten der Gesundheit und Wachstum der Fische es ermöglicht, dass intelligentere Entscheidungen getroffen werden, der Verlust reduziert wird und insgesamt wird eine stabilere und skalierbare werden Betriebsabläufe unterstützt. Hier waren die Business Benefits, dass 30% der Fehler reduziert wurden konnten in dem Vorhersagemodell. Dann konnte auch die Zeit reduziert werden, die bis zur Produktion in der neuen Benutzereinrichtung oder bei neuen Verfahren gebraucht wird, sogar um 50%. Und auch das Wachstum der Fische konnte um 7% erhöht werden für den Endverbraucher. Jetzt, wenn Sie noch mehr über die Success Stories von FF4 wissen möchten, können Sie gerne auf unsere Webseite gehen. Wir haben auch unser Booklet vorne noch ausgelegt, das Sie sich gerne mitnehmen können. Da gibt es auch noch Videos von den einzelnen Subprojekten, die sich da vorstellen und ihr Business Benefit. Genau, dann tauchen wir jetzt in die aktuelle Projektphase ein, Fortissimo Plus, kurz FF Plus. Wir haben eine Fördersumme von 24,5 Millionen Euro und das Projekt wird gefördert von der oder unter dem Programm Euro HPC JU Digital Europe oder Digital Europe. Projektbeginn war der 1. Mai 2024 und insgesamt hat es eine Laufzeit von 48 Monaten. Projektende ist dann Mai 28. Koordinator ist das HLRS, also die Universität Stuttgart, auch schon seit der Vorphase, also FF4. Und wir haben insgesamt 7 Projektpartner, die hier unten aufgelistet sind, zum Beispiel aus Slowenien, Italien, Frankreich, Polen und Spanien. Genau, dann der Überblick zu dem Projekt noch. Also unser Ziel ist es, dass, wie schon gesagt, europäische KMUs und Startups zu fördern. Die sollten aus den Ländern des Digital Europe Programms kommen. Branche ist egal und Technologie auch. Also wir haben von Gesundheit bis zur Ingenieurwissenschaften, so alles gerade dabei. Förderthemen, also wir haben 6 Open Calls, wie ich schon erwähnt hatte, die gliedern sich in 3 Experimente oder Business Experiments und in 3 Innovationsstudien. Die Experimente adressieren vor allem KMUs, die HPC noch nie benutzt haben, um ihr Geschäftsproblem zu lösen. Die zweite Gruppe, oder Thema ist die Innovationsstudien. Das richtet sich an KMUs und Start-ups. Und hier erwarten wir schon, dass sie Erfahrung mit HPC haben, aber bisher noch keinen Zugang dazu hatten, um ihre generative KI-Modelle weiterzuentwickeln. Genau. Gerne können Sie auch auf unserer Webseite schauen und mehr darüber nachlesen. Wir hatten gerade auch den zweiten Call für die Business Experimente. Die Ausschreibung lief von Juni bis August und Rückmeldung oder generell, wir waren sehr überwältigt mit 350 Anträgen. Es ist praktisch jetzt das Doppelte, was wir aus der von Call 1 tatsächlich hatten. Die Laufzeit der Experimente ist immer 15 Monate und die gesamte Fördersumme für die Experimente ist 4 Millionen pro Subprojekt, die bekommen 20.000 Euro maximal, dann 200.000, sorry. Dann die Innovationsstudien, wird die Ausschreibung jetzt dann im Dezember veröffentlicht, am 3. Und Deadline ist hier Ende Februar. Die Laufzeit der Projekte ist hier auf 10 Monate ausgelegt. Insgesamte Fördersumme ist auch 4 Millionen Euro und maximal kann jedes Subprojekt 300.000 Förderung erhalten. Dann ein Blick auf den ersten Call. Da hatten wir auf die Länderstatistik insgesamt 126 Anträge aus 30 EU-Ländern erhalten. 183 KMUs waren dabei und 40 weitere Organisationen. Aktuell fördern wir durch diesen ersten Call 19 Experimente und insgesamt sind es Teilnehmer aus 15 EU-Ländern. Die Innovationsstudien, da haben wir im ersten Call 62 Anträge erhalten aus 24 EU-Ländern und 83 KMUs und 36 weitere Organisationen haben sich da beworben. 18 Innovationsstudien werden momentan von uns gefördert und wir haben hier 14 Teilnehmer aus 14 EU-Ländern, wie hier auch aufgelistet ist. Genau, damit wäre ich auch schon am Ende.
Gut. Vielen Dank, Cosima. Genau, das Mikro nehme ich gleich, dann kann es der Nächste übernehmen. Vielen Dank. Also, Cosima Weyers, das Thema FF+. Genau, nach vorne kommt jetzt Mathis Bode vom Jülich Supercomputing Center und er wird uns berichten, was mit Jive, Exascale KI für Europa denn alles möglich ist und steht da nachher auch als Experte bereit. Bitte, Herr Bode.
Ja, vielen Dank für die nette thanks for the very nice introduction. I think we can switch back to English. Yeah, I'm Mathis Bode from Jülich Supercomputing Center. Just call me Mathis, it makes life much simpler. I will talk quickly about Jive, Jupyter AI Factory, one of the 2 AI factories that we get awarded in Germany. So you see here already like the partners that we have in Jive. So we have 4 German core partners, Jülich Supercomputing Center, Forschungszentrum Jülich, ADOTH Aachen, Fraunhofer und Heschen AI. Heschen AI is basically the joint group of all Hessian universities, especially focusing on AI. Nowadays we also have 2 AI factory antennas in Belgium and in Hungary, so it's a kind of a huge project. Let's start with this picture. So this was kind of in the news beginning of September when we actually launched Jupyter, and I'm a little bit lazy, so this is why I brought a video about Jupyter to explain what at the core of our AI factory is.
Jupyter. Aufbruch in eine neue Dimension des Rechnens. Jupyter am Forschungszentrum Jülich ist der erste Supercomputer in Europa, der mehr als 1 Exaflops erreicht. Das entspricht 1 Trillion Berechnungen pro Sekunde. Oder der Leistung von 1 Million moderner Smartphones. Ein Rechner der Superlative, für den am Jülich Supercomputing Center eigens ein neues, innovatives Rechenzentrum errichtet wurde, das Modular Data Center. In nur 8 Monaten wurde es modular aus 50 Containermodulen aufgebaut. Das Herzstück von Jupyter ist das Booster-Modul von Eviden. Die enorme Rechenleistung ermöglichen 24.000 Superchips, Grasshopper-Prozessoren von Nvidia. Jeder für sich eine Art Mini-Supercomputer, optimiert für wissenschaftliche Berechnungen und das Training künstlicher Intelligenz. Beim Training von KI kommen sie sogar auf über 40 Exaflops und machen Jupyter zu einem der weltweit stärksten Supercomputer für künstliche Intelligenz. Ein großes Basismodell mit 100 Milliarden Parametern trainiert Jupyter in einer Woche. Ergänzend hinzu kommt das Clustermodul von Partec. Das erste System mit in Europa entwickelten Prozessoren eignet sich besonders gut für komplexe, datenintensive Berechnungen. Und Jupyter ist mehr als ein klassischer Supercomputer. Er wird durch die Jupyter AI Factory zu einer Plattform für künstliche Intelligenz ausgebaut. Die Cloud-Infrastruktur Jarvis schafft neue Möglichkeiten, bereits trainierte KI-Modelle gezielt zu verfeinern und praktisch anzuwenden. Dies nennt man auch Inferenz. Viel Rechenleistung erfordert viel Speicherplatz und der findet sich in der Data Hall reichlich. Alle Module sind über ein Hochgeschwindigkeitsnetzwerk gekoppelt. Darin werden pro Sekunde 3-mal mehr Daten übertragen als im weltweiten Internetverkehr. Ein weiterer Aspekt ist die Energieeffizienz. Auch hier setzt Jupyter neue Maßstäbe. Sein erstes Modul rechnet effizienter als alle anderen Superrechner zuvor. Das Geheimnis liegt in der Kombination aus modernster Prozessor-Hardware und einer ausgeklügelten Wasserkühlung von Eviden. Die entstehende Wärme wird direkt auf dem Dach an die Umgebungsluft abgegeben. Und damit nicht genug. In Zukunft soll die Abwärme genutzt werden, um benachbarte Gebäude zu beheizen. Ein weiterer Schritt in Richtung Nachhaltigkeit. Mit Jupyter beginnt in Europa eine neue Ära des Rechnens. Ein Supercomputer, der mit seiner modularen Architektur bereit ist, Technologien der Zukunft zu integrieren. Mit Quantencomputern und neuromorphen Computern kommen Aufgaben in Reichweite, die heute noch als unlösbar gelten. Gemeinsam mit Jupyter werden wir die Zukunft des Rechnens in Europa gestalten.
Yeah, that is a quick introduction to Jupyter, which is also the name-giving part of the AI factory and basically the compute infrastructure that we will mainly employ in the Jupyter AI factory. Let's summarize like some details here again. So Jupyter will have more than one exaflop in double precision HPL performance. I mean, we have heard a lot of Shinika today. Jupyter is kind of 4 times faster in double precision HPL. In AI, it's even more. The key is like the 24,000 NVIDIA Grace Hopper superchips that kind of power the booster module, and we have Dragonfly Plus topology to being able also to run all of the GPUs at the same time in single applications. We have more than 1 exabyte total storage in hierarchical systems from NVMe-based based storage to spinning disk to archive. And well, everything is very energy optimized. So the HPL we will achieve, or we do achieve, with less than 20 megawatts. But the focus here is not just on Jupyter, it's also on the AI factories. And to make it clear what in our opinion AI factories actually are is, so it's about providing compute, giving or enabling big data spaces, AI services, but not just for, and this is where we traditionally come from, for research and that, but also for companies, which is a huge new difference now. As the video already mentioned, so our idea is that we use Jupyter and we extend it or further develop it with the AI factory in an advanced AI platform that is able of doing exascale AI, and that is also a little bit similar to what also people know from the hyperscalers. A crucial piece in all of this, and we have heard this also in multiple talks today, is not just training of models. Actually, for many applications, people use pre-trained models and just build models with AI agents and whatever. So I think it's a very important thing that we also think about inference. So really making models also available, not just training, but also then using the models. Because let's be honest, it's very hard to make money with training models. But if you want to make money also as a company, you have to usually do this as part of inference. So we have on one side like the Jupyter system, where we have more than 40 exaflops for training. So we are able to also train like European frontier models. But we also extend this, and this will come next year, with what we call Jarvis, which is an AI inference cloud where we have scalable and sovereign inference cloud where people can then also host their trained models. We have this sketch, but I just go briefly over it. So the AI factories basically want to provide everything like services, research, data facilities, software ecosystem, then training, inference, and this all embedded for everyone. So that's just AI factories in a nutshell. We at Jive, we focus on 7 different key domains. So Europe has these key domains, so we focus on health, energy, climate, media culture, education, public sector, finance, insurance, and manufacturing. However, we're not limited to that. So at the end, the user decides what they want to do. We have maybe some more activities in those domains, but every user is welcome, from engineering to manufacturing to whatever. So at the end, I think users should more select about the available compute and services and not so much about the key sectors. Data spaces is also a very important topic in that sense. So obviously compute is crucial for AI, but data is very crucial as well, maybe even more important. And I mean, actually in Europe, we have in the scientific areas, we actually in some of them already very, very good with data. So we had this example of weather, and we have actually from the ECMWF probably the best weather data in the whole world. We have the same from the Human Brain Project for brain data, where we have like the best data in the world. And we try to extend this now also to, let's say, more industry relevant data. So for example, there was announced this alliance also with companies here from the area for manufacturing, where also Jive is kind of involved. Yeah, so what is the status of Jive? So we started like this month, more or less. We have already 100 companies contacting us, also known companies. We have Jupiter, which is in the bring-up phase, but will be available or will be very soon. If you look at the compute in Europe or also in Germany here for the moment, then you see that the Jülich systems are the first two, the others are the next biggest systems in Europe, and then you see that actually in Jülich we have, like even, that is HBL, that is not for AI. For AI, actually the NVIDIA GPUs are even better than the AMD GPUs. We have about 85% compute because of NVIDIA. We have already an inference platform going, and we also it's highly also seen by politicians. So this brings me to my last slide. So I think we combine like very strong expertise in HPC, but also in AI. We have the exascale computer that is unique in Europe, and also now it's training of frontier AI models. We have Jarvis for inference in the next year. So I think Jive is something that is really driving the what we call in Europe the AI continent. Thank you very much.
Thank you, So, one AI factory, and now we have the next. Our next speaker will be Kaan Aytekin from the HLRS here in Stuttgart, where we have Hammerhai, actually the first German AI factory. And I hope your slides, well, they are there already, so the floor is yours, please.
Hello, welcome to HLRS, everyone. Today I will be presenting Hammerhai, hybrid and advanced machine learning platform for manufacturing, engineering, and research. My name is Kaan. I'm a research scientist here in HLRS in commercial computing. So Hammerhai is the other AI factory for industry and academia. It aims to empower startups, SMEs, and industries, as well as academia, with cutting-edge AI solutions for engineering, manufacturing, and global challenges. And primarily wishes to drive innovation, economic growth, and transformative advancements across Europe. Here on the figure, we can see all the other AI factories scattered around Europe, and we are currently not in production yet. And Hammerhai is led by HLRS, which has broad industrial expertise, which is already serving more than 70 industrial customers, such as Porsche, Trumpf, Festo, and also has high regarded certifications such as ISO 20001 and TISAX Level 3. And HLRS well-established user accounting and user help desk structure is also going to be an expertise transferred into Hammerhai, and not just in national level, but also in European level. HLRS experience in leadership in projects such as Accelerat, P2, and FF+, makes it ready to become an AI factory in Europe. And alongside HLRS, we have a very strong consortium consisting of LRZ, who is also very well known in the HPC industry for their expertise also in AI. GWDG from Göttingen for their cloud and data expertise, Karlsruhe Institute of Technology of their research and innovation leadership. And SICOS, maybe I need not to reintroduce today. So when we think about AI factories, we just directly think about data centers and GPUs, and well, it's mainly that, and we do not wish to reinvent the wheel. Our primary goal is to make the services available as quickly as possible. And as we grow, we will have our users driving our growth, and it's emphasized a lot in Hammer High. Actually, the user is at the center, and Hammer High just aims to become beyond just infrastructure. Hammer High will consist comprehensive AI services. I think this is very interesting, especially for SMEs and businesses who are wishing to become AI ready. We will be also guiding the users. And user support is going to be realized through our concierge service, which will be guiding our users in a tailor-made fashion. And we would like to enable seamless transition of our users into AI, but not just their businesses. We would like to also make sure that they find themselves a place within the larger AI ecosystem. And we would like to make use of our extensive network to also enable services that are offered by our partners and allied institutions. And quantitative facts, Hammer High received 50 million euros investment for the hardware, and an additional 5 million euros investment is made for the operation and maintenance. And the infrastructure, similar to Jupyter, is going to be focusing on not just training, but also inference. And it is going to be an AI-optimized supercomputer, a dedicated AI system. And it's currently in installation phase, and it will be available in 2 phases. The first phase will be finished within the second quarter of 2026, and the entire system will be ready in the second quarter of 2027. And by supporting the entire AI life cycle, what is meant is basically AI has this 3 pillars: data, model training, and model inference. And we would like to basically offer the support to our users in every phase. And what are the next steps? We have some already available facilities to actually make the AI adoption already start. We got the test access service, we got the concierge support service, and we got the compute and storage services from our Hunter system, as well as our Vulkan system. So we can support our users already in getting their hands dirty with AI. And we have AMD MI300As, NVIDIA A100s and A30 accelerators. And additional infrastructure will be announced as they become ready. And please visit our website to stay up to date with Hammer High.
So, thanks a lot, Kahn. Thank you. So, as you might notice, I'm not Victoria Scheible. Actually, she had a little accident and cannot be here today. She's fine, but it will take some time. So I promised to take over her part, and I will not take over, only take it over here for the presentation, but I will also then be the ED expert that you will meet at the speed dating. That's the reason also why, for my part, the ZIDE, actually, Murat will be the expert. So, ED Südwest, so what is EDI doesn't switch. Okay, yeah, that looks better. So EDI actually is, it stands for European Digital Innovation Hub. It's actually a network with, I don't know, more than 250. Yeah, hubs actually spread all over Europe from the Digital Europe program. And well, it is what it says, digital innovation hubs. And in our EDI Südwest, we have partners, well, from Südwest, from Baden-Württemberg, all of them. So like it includes Fraunhofer, SICOS is in there, Hahn Schickert, and Medical Mountains and some others. It's a mixture of, let's say, competence partners and networking partners. And the EDIs have four, sorry, I hope it doesn't break that easy. Have four main areas. So it's test before invest. So before you buy a computer, you can test it. It's about courses, trainings, workshops, access to finance and networking. And that's what we offer with the EDI. So there is a certain focus on health, on automotive and manufacturing. But it's not too close, where there are two actually EDIs in Baden-Württemberg. So you'll learn from Juliana about the other one. So what we are more in the southern part. And so if there's something comes up and it's interesting for the ADAICS, we'll refer to each other and vice versa. So whatever you have, we'll try to help you. So there is a technology specialization. So this is related to Hahn Schickert. They are very good at sensors. So things like edge AI. So they are really the experts there. But they're also in the next phase that's going to start hopefully in February next year. AI will be more important, and there will be also a stronger focus on AI at EDI Südwest. So green AI and HPC for AI will be topics that will support stronger next year. And the idea is really to provide services for single people, founders, SMEs, and especially the public sector. So like technological and financial consulting, training courses, events, and test before invest, really to try out things. And just an example here, there's a wireless sensor for the integration industrial transmissions. So there's a company from Nördling, actually I didn't know before, that's a manufacturing area, and Hahn Schickert supported them. But there's also things like networking and matchmaking. So a colleague from N&M Software called us and asked about some medical issues, and we, in this case it was actually SICOS, we are involved also in our Medical Solution Center case for Med. Medical Mountains is also a partner, so it was pretty easy to come up with some information and create a link to EudaMed, the European database on medical devices, which then actually helped M&M Software to get going in the medical field better than before. So you see, it's really a variety of activities. We also set up a digital maturity assessment, so to speak. This was mainly driven by BWCon. They have done it already for a large number of companies, which has the advantage that you can also get a comparison. So it not only gives you feedback about, let's say, on your scale where you are, but you can see where other similar companies are, so you know where you have to probably catch up to be more competitive. So that's really recommended if you want to try it. And yeah, well, as you know, it's been funded by the European Commission, so that's why we have all these logos there. There's also support from our local ministry, from the Ministry for Economy, Work and Tourism, and for the Interior Minister, which also handles digitalization in the state of Baden-Württemberg. And so if you work with us, you'll be part of the digital land. And so that will be it from my side, so hopefully see you together. I learned actually there are now 3 free slots for the afternoon session for the speed dating. And that brings me to Juliana. So Juliana Nichasu from the other EDI in our state, AICS. You're more familiar with that, so I hand over to you. Yeah.
Hello, everybody. Thank you for the nice introduction and already for some information about the European Digital Innovation Hubs Network. Indeed, it's going a little bit too fast. So indeed, we are one of the few regions in Europe that were lucky enough to have 2 European Digital Innovation Hubs. Here in our region, we have the EDI Südwest, as it was presented by Andreas, and we have the European Digital Innovation Hub, Applied Artificial Intelligence and Cybersecurity, which is coordinated by Forschungszentrum Informatik in Karlsruhe. Anyhow, we are both EDIs following the same goal that was set by the European Commission. Our purpose is to support companies in the region in the direction of digitalization, and mostly because our region is a little bit special in terms of the innovation level, which is very high. We are now focusing a little bit more in the direction of supporting companies in integrating artificial intelligence and cybersecurity solutions in their activity. So just very short about us, we started in February 2023. We will work until February 2026, but we already received, as our sister EDI, we already received the funding for the following years. So we will actually continue to support companies with our services until 2029. Our goal is, as I mentioned, to offer services in direction of digitalization to small and medium enterprises. So KMU is one of our target groups, but we also offer our services to public institutions. We are not alone. We are supported by 10 partners that are in our consortium, and we are working together with more than 100 associated partners in terms of providing the suitable solutions to the companies. The European Digital Innovation Hubs are working through a structure that was given by the European Commission. Because, as I mentioned, we are 2 EDIs in our region. We divided the topics, the application fields between us. Our EDI is focusing more in the direction of production, energy, mobility, commerce, service, and the public sector organizations. As I previously said, we are not alone. We are a consortium of 10 partners that are very well organized and very structured in terms of providing services to the companies, so that we can provide as much as possible and in as many topics as possible. Forschungszentrum Informatik FZT in Karlsruhe, we are focusing on mobility, but of course not only. We actually noticed that there's a huge request in terms of providing services to the production companies. So we are mixing our activities as much as possible, our services. We are working close together with Fraunhofer and KIT. And we are in our consortium also supported by companies like CAS Software or Steinbeis Europazentrum and Digitales Innovationszentrum. And in terms of providing services to the public sector organizations, we have the Technologie Region Karlsruhe working with us. We have a customer journey that we are trying to follow in support of the structure that was given by the European Commission beforehand. We are providing services in Test Before Invest. So we are, first of all, trying to understand better how the companies are working and what is the need of the companies. And we are then providing the services, let's say, personalized on the need of the companies. We are supporting them with technical solutions. We are working together. We are co-creating solutions. We are providing services and checkups in terms of cybersecurity. And when we found the solution, then we go further in offering also trainings. And in the case of further need of development for the solutions, then we also provide support to find investment services. Everything happens in the goal of building a stronger innovation ecosystem in our region. And this meeting today, I find it extremely important because we it is very important to connect as much as possible the infrastructure, the IT infrastructure, the AI-based services, and all the activities that we are providing in the region. What is very important, we are working in the direction of offering customized services, so we are identifying the needs of the companies, but we also offer public offers, public services like events or trainings or matchmaking events, speech events, so that we support as much as possible the companies, and we get to, with the information to the companies as strong as possible. A few information about each of the services that you can, that you will see and you will be able to hear more about in the next round of speed dating. We have the technical services. So I think that the presentations, as I've seen them, they are very technical until now. So you will be able to hear a little bit more about the use cases that we can build together, about the security checks and penetration tests that we are doing also, and all sorts of workshops and co-creation activities that we are doing with the companies to create new solutions to answer to the needs. Then, as I mentioned, we have the skills and training area where we are providing workshops, deep dives. We specialized in providing deep dives from the entry level of AI knowledge to expertise. What is very interesting in terms of providing the trainings, I think, and providing the services is that, and I think it's very important to mention this, we are providing all these services, but we found out that companies, what they actually need from the beginning is a very strong AI strategy. And this is what we are focusing now, and we are trying to support the companies as much as possible in this direction. Support to find investment, we have here consulting sessions that we provide to the companies, one-on-one sessions, but also open workshops, and we have also the innovation ecosystem and networking activities, as I mentioned, very active here in terms of events, in terms of networking, connections, and so on. Success stories in production, you see here a few examples. This is actually quite an old slide. We were extremely active in the last months, and we had many more application use cases in production in terms of providing AI-based solutions, first of all. In terms of energy, we are working with ZSW here in Stuttgart. They are providing their solutions in the direction of energy planning. And as I mentioned, in terms of mobility, we have all sorts of solutions that we developed in our research center. Please let me know if you need more information. I would be happy to provide you more information about our activities, about the services that we can provide. Thank you.
Thank you, Juliana. Yeah, this brings us to lunch about in time, so I guess everything's out there. And oh yes, I have some presents, so I hope that's not a mistake, but we give the presents to the speed dating experts in advance. So it's all a matter of trust. So yeah, Karin will give you. Oh, it's like a motivation, and we make sure that you don't have a lack of sugar or whatever. Yeah, speed dating. I already mentioned it. After lunch at 2 o'clock, speed dating will start here. So if you have a blue marker on your name tag, so it's 2 o'clock. If it's yellow, it's 2:30. All the others can wait. Okay, well, spend time outside. Those who want to go to the tour, they will be collected, and this will be just made by Hendra. Somebody will come and ask who wants to go to the tour, and the first 10 will be then at 2 o'clock, and if there are more than 10, the others will then follow at 2:30. So enjoy your lunch and communicate. Thank you.